everybody, and welcome to Handmade Hero. We are trying to fix a problem today. That is the problem that you can see. We introduced some kind of a bug, at least I think we did, when we really did some nice work with the lighting. And it's very efficient now and does really pretty dramatically large number of samples. But we have this light brightness contamination problem. I suspect it's actually due to a bug and not an algorithmic issue. I think we introduced some kind of a bug where we're sampling or filling something wrong. You can see when we don't have the light contamination, it looks great. I love the look of the lighting. It's fantastic. But we get this weird light contamination bug where, you can see this sort of weird effects with the lights where they over bright. And there's just something very strange going on that really to me doesn't look logical. I'm guessing that it's an actual whenever you have a lighting system, it could just be a bug. It could just be an algorithmic bug, meaning, you're doing this sampling slightly wrong, or you've got some kind of a math issue that's going to lead to feedback or something like that. It's certainly possible that that's what's going on. And maybe the reason we're seeing it now is because the lighting is running at such a high rate that, it quickly contaminates, whereas before it would be very slow or something like that. Totally plausible. But I also think it's very plausible that maybe we had a bug that just wasn't really uncovered by the old system. The old way the old system worked kind of masked the bug, or something. Or we introduced a new bug that actually is doing something fundamentally wrong here, that leads to this result. So either way, that's what we have to track down, and thankfully, it is somewhat detectable. So in other words, if I go into the code here, we actually have some checks that we can run that we did before. I think they were in the Lighting Atlas code here, where we can turn on this Light Atlas assert, and what that does is it slows things down quite a bit by just running over the Atlas all the time, looking at these texels and running this validate texel component call, right? And you can see that validate texel component call in here. It basically just does whatever check we want, whatever we're looking for at the time. And what you can see here is that the way of producing a valid text component here is we've got this range, -100 to 100. My guess is that, now we should really never have things that are below 0. I don't see how you would actually get that. We could check, but you shouldn't really ever be able to do that. So if we set, let's just see what happens if we set it to a guarantee that it's above 0. I'm not sure. It might be that it occasionally is slightly below, but I'd like to see. So I'm going to turn on the Light Atlas asserts here, and then we're going to see what happens if we run it. Do we ever get any light values below 0? Because I don't think we would, right? And the reason for that is that lighting is always summed. It's a sum, it's a weighted sum. And since none of the lights we don't have the concept of negative lights. We don't have in the game right now anything that's sucking light out of a region. So because of that, you would never expect the number to be 0, because we would never, even if we didn't clamp it, or anything else, you would never expect you to be able to sum, right? So if we check that, we now know that we can have kind of a lower bound there, but we also know we could now impose an upper bound, which is to say that our lighting system, because it is a summation of samples, we should never be able to produce things that get higher than the power of the light sources in a region. And my assumption is that we do, because that's how you would get this overbrighting here. I don't know what the level... Whoa. That's really cool. I don't know what the level of overbrightness is, but I'm hoping that this would trigger. Of course, it didn't. I'm wondering, did I do this wrong? Because you would think that would trigger here. The fact that it's not triggering here is a little suspicious. Maybe this was not actually on. Let's double check. I don't actually know. So here, the validate text component call will always return false. So this way, if we want to, we can say like, okay, look, it should stop right away. And it looks like it does. So that's good. I don't know why this 0 to 100, it seems odd that that wouldn't trigger based on what we were seeing, but I guess I'm wrong. I thought we tested this and it did trigger, so I'm a little bit weirded out about what's happening here, but I don't know. I mean, I guess we're gonna find out when we go here. Also, I suppose there's a separate issue, which is that we are viewing the specular lighting here. I'm sorry, the diffuse lighting here. I guess we haven't really looked at the specular lighting, and so it could be that there's something weird going on there. I'm not sure. That's a tough question, and I guess we'll have to look at that a little bit more closely as we go. All right, so I guess the next question is, can we do some kind of a bounds check here where we reduce this to something that does trigger? Is there a lighting bound that will trigger? And I don't know. If there isn't, that's a further clue as to what's going on, because I have no idea how what we could be seeing could be happening if the lighting values are always within range. This should surely trigger, because I think we actually have light values right now that are greater than 1. So again, unless this code is just broken, I would think. Yeah. Let me go ahead and switch this to debug mode. I'd like to see exactly where that's... I assume the validate text component... So I don't think that would be called there. I want to see what that's doing. I'm not entirely sure why it would stop there. On a push light call. It might have been actually above that, but we'll see. Okay, so we do have a validate text on the push ref call. That's just to guarantee that no light that we push in is brighter than the textile validation, right? So I'm really weirded out now. I mean, this is possibly good. It might mean that this bug will be more obvious than I was thinking. I was assuming this would take a while to hunt down because I was assuming it was going to be pretty weird, right? But if we can't even find a light textile value that's outside of this fairly narrow range, that might mean that actually this is a much more straightforward bug to find, and that we're not getting weird exponential light leaking or anything like that. So what's the brightest kind of light that we're sending down here? I don't actually know. It looks like we've got a 555 emission, and that's in some entity. I assume we're just doing like lights in the world, in our in our room generation or whatever. I assume that we have some kind of standard lighting here that we do. You can see here we have lighting that we're adding. I guess we iterate over these with the light spacing. You can see that here. This was just some lights that we added. And you can see there's some kind of a light. This is the code where we add it. I believe this is the size of the light, so quite large. This is the light amount itself, and I guess I don't know how the emissions works out exactly. Let me just double check that I'm interpreting those values correctly, because I don't remember what they all are. So add piece light is here. You can see it's like entity radius offset emission color. Okay, so no, I take that back. So this isn't the size of the light. I guess the size of the light is the first one. So it's this. That actually is the emission. So it multiplies this lamplight color. And so that would make sense. This is a 10 emission light, but each one of these is like around 0.5. So we would expect everything to be around a 5 power light, right? Makes sense. So I guess I'm not sure exactly what to make of this. So the weird thing about this is that I don't know. That kind of means that maybe this is just an exposure problem. like that could mean that because we just don't have an exposure curve in here, like I wonder if we're just that literally this isn't weird what we're seeing. If that makes sense. Because if we went into the validation layer and just said, look, you should roughly be, I mean, let's give it a little bit of headroom for numerical accuracy's sake, but you should just always be in line here. And then we go in and we nerf out anywhere that was adding. So that add piece light should assert right away. So we go in here and say, okay, let's knock those down to a value that's legal, that's light legal, right? In what we're looking at here, and we then run again, et cetera, et cetera. Like, let's try to get to a place and see, do we actually have this problem occur if all of the lights are within bounds, right? And I'm going to go ahead and assume that that's all fine and switch to the release build here. So here's our lighting running where everything is basically kept within the 0-1 range. And hey, guess what? We don't seem to have this bug, right? So to me, that sort of suggests that actually maybe the bug is just that we don't have any exposure. There are some light flickering artifacts that I'm not sure what they're from. That looks kind of a little bit broken, but it might just be because the lighting region is a little too small, right? If you look at where we're checking, you can see like, okay, the light as I move here, when the trees page in, that appears to be when that lighting changes. So it may be that we just need a slightly larger region than what we're currently using. If that makes sense. So we may need just slightly bigger. It looks like there's a light that's too bright here. I don't know who is adding that light. But so there is somebody still adding lights that are too bright for them. Again, that's okay, because I don't think we actually want to fix this problem that way. I just wanted to verify that that was the case. And then we'll think about this a little bit more. Okay. So if that's the case, then I think I've learned probably what I need to learn here, which is that this is actually not necessarily actually light contamination. This is maybe just an artifact of the way our algorithm convects light. And I guess I'm not really sure. So here's some kind of confusing aspects of this. I'll just go through them. So first of all, why do the lights in our system have fall off, right? Because if you notice, like, we don't actually have any light fall off coefficients or anything like that. The lights are just the lights. We never programmed in, you can see here, what appears to be light fall off. But we didn't program any light fall off, so why did that happen? Well, the reason that happens is because as you get further away, it is simply proportionally less likely that you will hit the light source with the rays that you cast. So the inverse square law is not actually in our computations, it's in our casting. Because we cast a fixed number of rays out from every light sample point, so each of the light probes casts a fixed number of rays, the percentage chance that any of those rays will hit a particular light source goes down with the inverse square of the distance away from the light, ergo the lighting ends up with an inverse squared fall off. But we never wrote that in there. It's just an artifact of sampling. Exactly the same reason in real life that you have inverse square. It's because if you emit photons, the chance that any one of those photons hits a particular region of space is going to go down as you get further away from the emitter of the photons, proportional to the inverse square law, right? So the inverse square law is literally just there as a thing that you get when you sample lighting the way that lighting actually gets sampled, right? So that's why we're getting this fall off. Now, the thing about the overbrighting is we also, when we throw out a light, like when we cast a ray, if the ray goes a certain distance and doesn't hit anything, it just samples the lights from the probe in that area. And it's possible that that algorithm, because that gather does not have the inverse square law in it, right? It may be that when you are in that state, first of all, I guess let me do this. Suppose I just turned that off. Like, suppose we hack into our grid raycast, and the code for the grid raycast is going to just be, if you don't hit something, like if you're going to bail on the grid raycast because you ran out of walks cycles, like you went too far or whatever, like this, right? Instead of doing a probe sample p single or whatever, we somehow turn this off, right? So in the code, like in here, we just don't. I mean, another thing we could do is just force it to go all the way. So we just say there's no such thing as grid walk iteration. This termination condition is just not going to happen anymore. I don't know if that'll be sufficient because it still will happen at the edges, but presumably that's okay. It might not be, but we'll see. So suppose we run it that way. Do we still get it? We do. So that's a little weird because I'm not sure why that would happen. Like I said, the inverse square law should still be in effect there. So I would think that you would still get the fall off unless I'm misunderstanding something. I suppose there's a occlusion. And a hit emission. So I suppose we could do something like a hit ref color gets zeroed. Like, so suppose that inside here, when we terminate, we set the hit ref color to 0. I think that would do it. But I'm not sure. Okay, so that at least seems to confirm my suspicion, right? If we end up going, if we would have hit a termination criteria here, I still see some weird, like, I don't know what is going on there, right? That seems a little weird, right? So I think we got a little bit more bugginess going on here, but just in terms of looking at what happens, you can now see that the contamination is no longer actually occurring. I don't know what exactly is happening there. Like, in that one particular case, we can get the contamination. So something, it still feels wrong. It still feels like something pretty busted is going on there. You know what I mean? But you can see if we just don't allow, if we don't allow that sort of spread to occur. So somehow, like, these rooms where we have I suppose it makes sense because it's green. These rooms where we sort of have the green lights seem to be the only place that this actual problem comes from, I guess, which is a little weird. I'm not sure why. Hey, there's the puss. So this is interesting. I wonder, this is kind of a separate issue. But, let me look at this a little bit more closely. Oh, and also let's draw occluders. And like basically let's draw the spatial partition. There's like a draw spatial grid, debug draw spatial grid function here. And like we'll get rid of cell bounds. We'll draw the actual pieces that are in the spatial grid. And I'll turn on rendering of that just so we can see like what's going on with that. So, you know, as you can see, there's one of the interesting things about this is there's no actual pieces of geometry with me because we turned them off. Like we don't push a light on there or anything, as far as I can tell. There's nothing going into the lighting grid. So my positioning in the world should not really have an effect on what's going on. The scrolling might, like I said, because, you know, it new things come in which can affect the lighting as a global solution that's happening on basically everything in this blue square. So as the blue square slides around, you would expect the lighting solution to change to a certain extent. But it doesn't make a whole lot of sense why it changed like that amount of change. Also, another thing that's very strange is it seems to only happen on quarters. Like, do you notice, like, wrong, right. Wrong, right. So when it scrolls 1/2 of the way, you know, when it's done one click, it's wrong. When it does another click, it's right. You know what I'm saying? And so that feels really odd. It suggests that maybe there's like a bug with the fact that, you know, the way the system works, if you look at the spatial grid is actually aligned to... The spatial grid actually has like four atlas cells per grid square. There's more in each grid square. There's 4 grid squares in one spatial atlas. The reason that we did that was because we were, you know, based on our metrics, we found that there just wasn't enough geometry in one of those square. Like there wasn't enough geometry in a single grid square to justify actually walking that many. You know what I mean? So it turned out to just be more efficient to have more of them in there, and, you know, maybe that was a mistake. I'm not entirely sure. It could be that it was. It could be that it was, but either way, whether or not that decision was a poor one has fairly little to do with the fact that it definitely seems to have an effect. Standing right there allows the light to leak. Standing right here doesn't, and there's no real explanation for that I can think of, right? I guess one thing I could imagine being true is if that has something to do with the fact that the boundary is possible to hit in this case and not really possible to hit in the other case. I say. The fact that those leaves are kind of stuck as well is kind of weird to me. You know what I mean? Like, why is that some kind of a NaN sort of thing? Or, like, why are those unable to clear? I don't quite get that. So, presumably, if I clear them out this way and I go back in, now they would be right. Um, but, like, that's very strange. Hmm. I say. I mean, I literally have no idea how to explain that pattern. Do you? So I think we need to figure out some way to test this scenario more stringently. I just like this is bizarre. Um, and I would say like it's gotta be a legit bug, meaning I mean, how could that be like a math error, right? Like how could that be like, oh, we're just sampling poorly and we should weight the samples different like that's gotta be a bug. Like, oh, hey, you're sampling outside the bounds of the thing, or like there's some like way that like uninitialized value can get in there, right? Um, but I don't have a good strategy for it at the moment. Let's start by drawing the octahedral values, since there's like looking at the spatial grid didn't really tell us very much. We do know that something about that stagger looks wrong, meaning like as we kind of um so there is the fact that when light probes are inside a light region, we don't update their value. I wonder if that has something to do with it. We should probably look. But here's our actual light probes, and you can see. So this light, this is a bug we have right now that we need to fix at some point. We just haven't quite decided how. But it's actually removing light from the system, so I doubt it's involved in this. Which is that if a light probe is inside a light source, it erroneously gets set to no light. You know what I'm saying? So there's that. But again, that's if anything helping us right now because it's not providing light contamination. It's actually like forcing those light samples to zero. So that's not really implicated in this case. You can see there's some weird like you can see the sort of weird light changing here, and the I feel like that's a little bit of a clue. So if you notice, when the light, when there are not, when we would be going outside, right? That's going outside the There is no wall to stop things getting hit here. When I hop forward, now there is. When I hop back, you can see that the light changes to a green tone. But why? Right? There's no reason why the lighting should become green at that point. I don't think. So the fact that not having a wall makes the lighting green is kind of confusing. Now, maybe it's not because these lights are sort of a little bit green tinted. And I suppose maybe for the sake of our current predicament where we're trying to debug things, maybe I should see what happens if we don't do randomized lamp lighting. So, for example, if instead of randoms here, we actually force all lights to be pure gray, right? Like pure white. They don't shift the color at all. Does that still happen? I don't know. Let's find out. So it looks like the answer is no. So the green is maybe because these lights were green. I'm not sure, right? But you can see that that had to be the case because now it's not. Now that everything, so it really just gets a little brighter as you go and these lights get paged in, which again suggests that this wants to be expanded a little bit. It looks like maybe these lighting bounds are a little too conservative. It should be larger, the region that we're lighting, and that's fine. But that's sort of a separate issue from the actual bug with the light contamination. So if we go, now that there is no bias there, like the lights are all pure white, or I should say pure gray, I don't know what you want to call it. They're color neutral. Can we still get the bug where we get the weird green here? I mean... weirdly, the answer to that also appears to kind of be no, which is very confusing. Because that, I don't know why that would be the case. Does that mean that you just have to exceed a certain power value before you can get that bug or something? Like, where did the bug go, right? Where did the bug go? So assuming I set these lights to the maximum value that they could have picked when we did randomized, so I'm going to set them both to 7. So it's basically going to, yeah, it's just a more powerful light. Shouldn't it now, it should have the bug, right? I mean, if it doesn't have the bug, I don't know what's going on. Yeah. Although it still doesn't quite contaminate. There it goes. So this is really confusing because that almost suggests that somehow this is not a bug or not exactly a bug. I don't know. It must be, though, because how is it happening? How does it leak only on the quarters? Let's think about that. Something's up. Something's up. So how are we leaking only on quarters? How's that possible? First of all, can we delete some of this code? Like, what do we use some of this stuff for? Nothing, right? We don't care about quadrant index. We ask for the cell center for wherever it is that we are. Do we care about the remainder? We do not. So that can stop coming in here. Right? So remainder is now not something we need. Which is great. Again, that's because we now do the stepping automatically gets solved. We don't have to use tables anymore. So yeah, is it that this computation is wrong and we're sampling the wrong places somehow? hasn't. I don't understand. Like, I can't think of a real reason why that would change. The reason that doesn't make a whole lot of sense to me is because I don't see why it would make a difference. Even if you step through the spatial partition incorrectly, I don't understand why you would get that light leaking. It doesn't really make great sense. I guess if you suppose that the light, somehow you always exited with a value that was producing some kind of an odd clamp, then if you put a light always... If you imagined that there was a bug in the light tracing so that when you hit this bug, or that you oftentimes, because of this bug or whatever, end up clamping to, let's say, the maximum or minimum bound of the lighting volume, then you could imagine getting the light contamination because you have placed, when a light source ends up locked into that placement because that's where you would keep sampling, right? It's not a good idea, what I'm saying, but it's an idea. It's better than what we've had so far, which is not an idea. So just to be more concrete about what I'm trying to say here is, suppose that we go and we look at an area that's having the light leaking versus a time when it's not. So let's suppose I hop back here. Like, I'm not getting light leaking right now, right? And if I zoom out slightly to show what the lighting volumes look like, you can see that the corners currently don't have a light source in them exactly, right? By the way, anytime I say exactly, did y'all ever watch the Qualcomm keynote, the most amazing keynote like ever given? Where like it has Bishop Desmond Tutu and Steve Ballmer and Big Bird and Maroon 5 in the same keynote. And like Steve Ballmer is like Disney's Where's My Water application, like that one. Has anyone seen this? Anyone? Has anyone seen the Qualcomm keynote that I'm talking about? Are you serious? Okay, good. I was hoping someone had seen it, because I'm like, if no one's seen that keynote, it's the most important keynote ever in the history of time, because it is so amazing and ridiculous. Like, it's hard to make it all the way through because it's so cringy, but at the same time, it's easy to make it all the way through because it's so nuts. You're laughing the whole time. Embarrassed, but laughing the whole time. Anyway, the reason that came to mind was because at the very end, well, it's not the very end, but almost at the end of the keynote, the CEO guy, I think it is, asks like one of his underlings, right? It's like, hey, were you born mobile? And the guy goes, not exactly. And it always just sticks in my head the way he says that. It's like, not exactly. And so whenever I say exactly, I sometimes get yeah, it's the one the most insane keynote ever, Qualcomm CES 2013 is exactly the correct one. Yes. No, it does not. It does not the one where Steve Ballmer says developers. I don't think that was a keynote, was it? That was a Microsoft company meeting, I think, maybe. That he said developers. But yeah. Yeah. Of the things you have to watch, like, obviously, like, everyone should at some point watch the one where all the Microsoft guys are dancing on stage. Like, the Bill Gates, Steve Ballmer dancing one is amazing. you should watch that for sure. But the Qualcomm keynote is an absolute masterpiece. I have no idea why they thought any of it would go over well, and it just keeps getting more ridiculous. Like, why is Big Bird showing up in the middle of this thing? How is Bishop Desmond Tutu in the middle of this thing? Like, it's so nuts, and none of it comes off well. And not only is Big Bird in it, but a Qualcomm guy or somebody, or maybe it was somebody from Sesame Street's, like, app division or something, is also, like, has a Big Bird, like, hat and wings on, but not anything else. Like, it's so incredible. Like, you have to see that Qualcomm one. It's so nuts. I cannot even tell you. So I highly recommend you watch the Qualcomm one. If you can't handle really embarrassing videos, then you probably won't be able to watch it because it's incredibly cringy. None of the people on stage. Well, I feel bad. There's like 3 people who were clearly actors hired. They're like supposed to be these born mobile. They're like young people, 20 something or whatever. Those people were probably actors that were hired to do that role, and they probably were hating their life for the entire time, but happy to get a paycheck, I'm sure, as any struggling actor would be. But oh my god, I feel bad for them, because they're like, all they can do is read the frickin' script that they were handed that's terrible, right? And so I do feel bad for them, but everyone else, it's like, why did you do this? Like, why are you doing this? It's so terrible. Anyway, yeah. I'm gonna go back to debugging this lighting, but it's a true cultural moment. Anyway, not exactly. These corners don't have bright things in them at the moment, although they kind of do. Like, that's a light. Oh, but that's not a corner. This is the actual corner. That's the corner of a room, not the corner of that light. That's not a light. That's not a light. That's not a light. That's not a light. There's no... In fact, there's no lights anywhere on these 2 edges. There is a light on this edge. Here, and here. So, I don't know. If we then move forward to the light leaking part, which is now... although it's not fully light leaking yet, the corners do not have light sources in them. So that's maybe not concerning, I don't know. Here is an actual light leak scenario. And I don't know what to make of that. I don't know. My theory doesn't seem super likely, right? I mean, it doesn't look like any particular area is having this problem. I would say I don't know where these people are getting their lights from. I guess it must be that they're hitting here and somehow picking up samples from inside, but it doesn't seem like that should really be possible because these are full occluders. So you would expect it to look more like this does. And the fact that they are able to get lighting is a little weird. Although I guess it looks like it's actually coming from over here, maybe. You know what we probably need is like a clearing button so that we can clear out the light atlas and force it to recompute from scratch. Because although every frame we recompute the lighting, we do it with the, when it samples the lighting, it's got to sample it from something. And that something is whatever the last frame's lighting state was. So we recompute the movement of the light every frame, but we need some idea of which lights hit what surfaces. And so the last frame's light probe data is what we use for that, which means that there is one frame of feedback, and we'd like to be able to clear that out right? Because in a case where you have a feedback thing like that, right? Okay, more clues. I just saw a clue. Like, how is that happening? Do you see these? Watch this row. It's like there's some kind of a way that you get into a state where people who are not getting any light suddenly get the light. Right? How? And it's sudden. Like that it's not even it's not even like a slow. Like there was it slow, but there it's instant. This is a real head scratcher. We need a plan for investigating this. We need a plan for investigating this. And I don't have one. Part of the reason I don't have one is probably because I don't do rendering for a living. You know, I'm guessing here that if like you were the kind of person who does lighting research for NVIDIA, you would probably have a pretty good idea of how you would go about debugging this, right? And I'm guessing like, you know, they would be like, oh yeah, you should probably put in some of these checks and, you know, or draw this, you know, I don't know, something like that. And we don't know that, but, but we need to figure it out, because otherwise we will never have our good lighting that we basically have now if we just didn't have this bug. So we have to figure it out, which means we have to figure out a way to debug it, which means I have to think of a way to structure the debugging to look for it. So we have some clue, which is to say that when we see something like the bug in an isolated area, so here, we do know where it's coming from, because the sidedness of the drawing shows a siding, where we can see like that the thing is coming from a particular direction, right? Right there. You can see that it sort of comes from one direction more than another. Right there, it's like it was coming from back behind it. And instantly, which makes no sense. I don't get it. So So let's suppose that we did not ever allow any feedback. I'm assuming that we wouldn't see, like you can see here, look, it's all telling you, right? Like those little things tell you which way the light comes from. The light like snuck out around here, came down this way, and now these are all getting light from that direction, right? That's what's happening. Presumably because the ray that cast goes all the way out to like here or something, or I guess it can hit the ground, right? And pick up samples from the ground. That just makes no sense. What is happening there? How does it go back to what looks correct all of a sudden? Is that because those values have like wrapped or something? Wait, but they can't even do that because we're checking for that. This is currently running the validator, which means no light is allowed to go above 10 in the first place. Oh, I should, because I'm now back at the code, let me explain this. I think someone was asking, correct me if I'm wrong, I saw someone go by in the chat. Someone was asking, like, is it a bug that there's a Y value used in an X computation, and vice versa? So the answer is no. It's supposed to do that, and the reason it's supposed to do that is because what's happening there is it's using, it's the code for walking along the grid is basically a Bresenham. Like, it's a very simple, we wanted to have a very simple way of stepping through the grid. And so what we did is when we step through the grid, we just look at how far off of the ray that we're casting each possible grid square would be that we could step to, and we step to the one that's like the closest to the ray. And when you want to measure the distance from something to a line, you measure along the perpendicular, which of course is x, one is x and one is y. If you want the perpendicular, you flip them, right? So, yeah. You can also see here that this is where the negative comes in. Probably these should have both been a plus, because it is a little confusing. Like, when I just looked at it, I was like, why isn't that negative? So, like, arguably, like, it's probably the case that in here we probably should have done that as a plus. So if, let me just change that. I think that just probably makes more sense. So if we do stepping delta x here, you can see, like, it only gets used in these two places. This should probably be a plus. And then when we compute it up here, just so that you can see, it probably should have been like that, right? So, basically, like, instead of that being negative here, what the heck? All right. What is happening there? I don't know. Anyway, we change it to a plus down here so they both get added, and then up here it's got a negative in front of it, right? And that's just because, it's like, when I looked at it just now, I was like, why isn't there a negative? It's like, oh, because we left the negative down the bottom. Which is, if you're looking at the code here, when you set it up, it just probably makes more sense that you would do that, right? Like, it doesn't, just seems a little more sane. Yeah. That's all. Yeah, Just Slavic, yes. You had the same thought I did, and so that's why I wanted to change this notation, because now it's much easier to see, whereas before, when it was distributed down here, that just, it's not like one's right and one's wrong. They both compute exactly the same thing, but it's easier to see that you did it right when it's all in one place like that instead of spread out, right? So, you know. Unfortunately, that has nothing to do with our bug, or maybe it has something to do with our bug, but we don't know what it would have to do with our bug. So we don't really know. We have no idea where this bug is coming from, and we don't really have a particularly strong idea about how to look for it. We do know that there's some kind of a strange alignment issue. So we have a little bit of a clue, which is that somehow when we have the alignment off, maybe there's a, here's one thought. Maybe when we get the alignment wrong, there's some kind of like when we walk the grid, we're walking it incorrectly and we miss, we can like tunnel through some occluders that we shouldn't be able to tunnel through. I don't know that I think that's a high percentage chance, but it's something we could think about. It'd be nice to get these folks here to maybe trigger again, and maybe we could use those as a case study and go inspect how the casting is working. So, part of the problem is that you can also see that like those are not the first people contaminated, right? So it's like it has to spread around the outside first, maybe. Let's look more closely at the order in which that contamination contaminates. Like, where does it actually come from? So it actually did start right there. Right? Like, it did legitimately start right there. That's the first place that I saw it get bright. So I guess I'd be interested to know if I don't know which index that is. Yes. Yes, we now know the answer to the bug. And you know what? We probably should get out the owl of shame for this one because I literally frickin' said this before. I don't know where that owl went. Let's go find it. All right. Well, so that was embarrassing because, as I was saying before the Owl of Shame paraded around, um, so I literally said we would have this problem. I don't know, we could go back and check the tape to see how strenuous I was about it, but I literally called this problem before. And then I forgot to actually go deal with it, right? So you know, maybe I can chalk this up to streaming because a lot of times if you stream only so often, a lot of times I feel like a lot more on the ball when I'm programming, in my normal job day to day. And a lot of times you forget stuff or stuff gets messy for no reason in code when you are streaming. It should be cleaner, and it's not because you never have that kind of clarity. But essentially what happens is when we are casting, we removed Z because now there is no the spatial partition is always the same in Z, right? But what we neglected to do, and I specifically said this, what we neglected to do is actually stop the looking through the spatial partition when you exit the cell in Z. So as a result, if someone can leave through the floor, so anywhere there isn't an underneath tile, right? And similarly, you would get the same on the edges, right? If somebody casts just out that direction, and instead of leaving the green volume, they get out the bottom and go straight, far down or something, right? Although that seems like less of an issue. It probably is more just these ones in here. Then you can easily have this problem. Now, there's a couple of different ways we can deal with this, and I'm not exactly sure which one we want to, but I would start by saying maybe the best solution is actually not to fix this problem and to always have floors everywhere, because in theory that should be fine. Now, we probably want to put something in that validates that never happens, but you see these where we're missing those floor tiles there. I don't actually remember why we have that problem. I think it has something to do with how we fill in the world. Because remember, we don't really have much in the way, I think we called it the apron. We don't have much in the way of room generation code. Our room generation code is pretty crappy. It doesn't really do anything interesting at the moment. But you can kind of see how it works here, right? It iterates over this stuff. It looks for overlapping entities. And I guess if it doesn't find any, it puts them in there. Why it doesn't have any only on that side, I couldn't tell you. I suspect it's probably because when we changed how things were aligned, this code is probably now wrong. When it iterates over things, it's probably wrong. So this get total volume thing, this code, I don't know, we'd have to look at. I'm not sure I care about it at the immediate moment. But I would suspect that this is probably the issue, is that it's not actually add radius to get total volume of tile, EPS, yeah. I mean, one of the things that we should also do here is collapse this to actually just using a grid, which, currently we didn't really do that. Your people are going to send an owl of shame to Microsoft, like an actual owl? It would have to be the biggest owl. In their new campus that they're building, Microsoft is building some new campus thing. I don't think it's done yet. But they had uh, this thing, this, right? This should just be a giant owl. Like instead of like whatever they're thinking this is going to be, it should just be a giant owl of shame in this thing. Like just absolutely huge. You know, something that's several times taller than the actual tallest building on the campus, right? Um they have the same bug. They do. You're right. They obviously have the same lighting bug. They haven't fixed it either. Um So like they've got uh plans here. They've got big plans, but I think this should just be a giant owl of shame that just like looks. And you know what would be even better, Microsoft, if you're watching this? Put a giant owl of shame in here, but put it on a rotating base so that during the day, like the owl of shame just rotates like a clockwork owl around and casts its gaze of shame upon each building, like in turn, because like we know that the only thing that anyone's doing in any of these buildings is shameful. So you might as well acknowledge that with a giant owl of shame in the centaur. That's my feeling anyway. That's my recommendation for the Microsoft campus, is a giant owl of shame that looks at all the employees with a shaming gaze. Okay, so we have been shamed as well today by the owl of shame. Let he who hath no owl cast the first shame. And we certainly have been shamed today. So I think the solution to this problem should probably be like we could solve it by in here when we cast array figuring out what the t value is that would exit the grid in Z. But my suspicion is that actually what we should do is just make sure that there always are bounds, because you want the lighting to work properly, and you shouldn't really be able to exit the cage out the bottom. I don't think. Maybe you should. Because I feel like you should just always hit something, and that something is either like a black tile if it's a pit. I don't know. It feels like you should always hit something, but maybe that's not true. I don't know. So it's hard to say, but there's two ways we can solve it. One is we could go in here and say, look, there's going to be a clamp on Z that we probably, I would say it would get enforced maybe. Maybe it would get enforced in the step where if the T terminate times the ray would put us outside Z, then we just, that doesn't count. It could be here. You know what I mean? I guess let's see what happens if we do that. So in here, if we make some requirement that we're going to clamp the T terminate to a bounds that has to do with Z, that seems pretty straightforward. So that would be like. That would be like having in here an F32Z or something where we just keep a z that steps along the ray and we break whenever we would have left the cell. I really don't want to do this. Let me explain why I don't want to do it, since I'm not probably making much sense. So I think we do want to just go fix the room creator and call it a day. So let me explain why I don't want to do this. So suppose that is how I was to solve this problem. And the game does take place in a 2D sort of environment, but it is somewhat 3D, right? Like, it still has, like, we're kind of allowing things to move in 3D and think in 3D. So my fear is that, let's suppose that I do fix this problem by just enforcing, when you look here, you can see the bounds are this green thing. If I did force it to stop when it hit the bottom of the green thing, well, you could still get pretty far outside your square, actually. If you cast, let's say from here, and maybe this wall didn't go all the way down, like, who knows, even if it does, before I hit that, I could easily get too far away, right? So I would still end up potentially pulling light from sampling that I really shouldn't. You know what I mean? So I think we want to constrain it, and maybe the answer is the reason for that is that this has to be way more constrained. Like, maybe this is far too tall, and you're like, look, you should constrain it the other way. But I think the smarter answer is just always build closed geometry so that you always hit something, like a valid thing, because that's the actual thing we want to have happen. And so it seems like having this like bogus space around is probably not the right solution. So my guess is that we really just want to fix this code. Unfortunately, this is not the code we're ostensibly working on, so I would rather have not have done that right now, but I think there really isn't any better solution. So, yeah, that's where we're at. So when we do this overlapping entities exist, I'm assuming that's what's failing, but I guess we don't really know. If we were to add something obvious, we probably could see if that were the case. By adding some other thing, like instead of, like, here's just my suggestion. Like, suppose we went in here and said, all right, if overlapping entities exist or they don't, will actually be something else. So we say, here's the predicate, overlapping entities exist will be in here. And rather than doing an if statement, we're always going to create this ground cover thing where we place this random entity here. And I don't know why we're adding collision volumes to it. I think probably for lighting, I would guess. So we're placing these collision volumes in here. And then what we want to do is we want to say we're always going to add one of these. And we're going to add one of these like just floating in the air or something when this comes back true, if that makes sense. So when we say like height equals random between 5, 1, whatever, this whole thing, make relative, get volume from min z. To be honest, why is that not varying the height of this thing? That seems a bit weird. I guess because it's only the collision volume. That's kind of weird. So you're telling me the collision volume is randomized, but the placement, this is some weird code. I don't know what. Oh, we do a ground P thing here. Yeah, I don't know. Anyway, this code is a bit weird. I don't feel like the ground is uneven, but this would suggest that it was. So I guess I'm not sure I completely understand. Before I do this, let me see what's up with that. Is that really what's happening there? Is ground uneven outside the generated rooms? I guess it is. That's definitely uneven. Okay. I guess I just didn't look at it very closely. All right, so that is what happens here. That's fine. What I wanted to do is say, okay, let's suppose that the height is always clamped to something like very low, or maybe the p-value is dropped quite a bit lower. So rather than this if statement, we're just going to say, okay, look, if it's overlapped, then the ground P is just going to have like some, large amount subtracted away from it so that we can see where like we're getting overlap and where we're not. Just so I can verify to myself that that's actually the problem, because I don't know if it is or if it isn't, right? So let's see. So, of course, one issue is I probably should turn lighting off for this because I can't actually see outside without that. But, what are you going to do? If I look... I can't even really see. I mean, I guess I can see that I can't see through it, so I guess that does mean that there is something there. Let's look in one of those gaps. Like that was a gap, right? All right. Now, I'm a little weirded out because it doesn't feel like this ground P actually got dropped, though. It looks like they're all at the correct level. Doesn't it, sort of? Oh, that's just for the trees. That's just for the trees. My bad. Let's do it for everything. But I think that answered my question, because you could see that it filled in all the holes. So I think we're okay. All right, so let's see here. These are all overlapped, so they should be low. And I guess they are. Let's make it more pronounced than that. Let's drop them way down low. That doesn't seem to have done anything. Why didn't that do anything? Anybody? Anyone? No? Any suggestions? Anything? Anyone? Because that should say any time you would have overlapped something, you should be placed very low down, right? I mean, that should be extremely low. It should be like way sticking out the bottom. And yet, nothing is sticking out the bottom. Everything is flat. How is it possible? I ask you. What am I missing? This is the p-value we're using, right? Maybe? Let's take a look. Because I'm obviously doing something stupid. Again, this isn't the code we were supposed to be working on, so I kind of got to page it back in. Let's go ahead and check out this function here. So, like, we're calling it... I mean, that seems like a thing, right? I don't get it. So I guess one thing is that it's centering that's kind of weird. So the volume... Get max C center volume. Okay. So that's a little weird. Well, is it though? So the volume got created. If we look at what the two values are, it's like Z10 to Z11, more or less, right? I mean, that's what we ended up getting. And the volume, I mean, that means that the entity placement is at -12, and the volume is... I guess offset from that. I don't really understand how this code works at all. I guess what this is saying, this is interesting. So what this is saying is that actually this make relative call is assuming that this is actually, this get volume from min z, this is not based off of the p-value. So really that doesn't adjust anything. It's just saying, look, this is going to be, we want something that's going to be relative to this p where we're placing the thing. So that wouldn't actually do what we were trying to get it to do. It'll just offset it. So really, I guess what you would do is you'd do it here. Yeah, this code kind of sucks. I mean, it's fine, but that's just kind of just unintuitive. One more pass over the room gen stuff, and I think we'll be more in business, which we'll want to do before we get much further. But that should work now. Things should now be sticking out the bottom when they are overlapped, right? I should think. I guess I don't know, but let's find out. I'm hoping not. I mean, everything shouldn't be overlapped anyway. All right. So the things that are overlapped are now gone, which I think is what should have happened. They're so far down they won't even be in the spatial query, I don't think. So now we should be able to do them more reasonably. So we'll push them 2 units down, which I think will still be inside the spatial partition to be pulled in, but so we can actually see. Yeah, you can kind of see them now. Of course, the lighting makes it difficult, but you see there? Right? We should probably try to turn off lighting or something just so we can see, but, you know, hopefully, maybe we can just look at it this way and see it here. So let's give it a shot. I'm gonna hop out to the outside here. Looks like we overflowed our entity count there, right? This assertion is we don't have enough space to unpack an entity, which is kind of nuts. Is that really possible? What if that's a bug? You wouldn't think so, right? Because the max unpacked entity count, excuse me. I guess I don't know what we normally set that to. Max unpacked entity count is max sim region entity count. That's a lot of entities. Is that really the case? I mean, it could be, I suppose. I will temporarily up that limit, but we don't really want that to be that high because it shouldn't have to be. All right. So if we now look, we should see, yeah. So you can see that those are exactly what I assumed they were, which is they're down, right? So, yes. I mean, the problem is that we are reporting those as overlapped when they're not overlapped, which is what I thought, right? So, with that in mind, I guess the question here is, what do we do about that? Because this code is obviously broken. So something about the way the overlapping entities exist function works is broken. And it's reporting that there is an entity that overlaps the entity we're trying to add, even though there really isn't. Which, again, wouldn't be a problem if we had an actual grid, but because this is not really a grid, the whole thing's in 3D and we're just pretending we have a grid. You know, hard to say. So if we get the total volume of the tile and we are subtracting epsilon from it so it shrinks inward slightly, for some reason we're still registering a hit there, like as if there is some volume that's colliding. And I'm not really sure why. So let's take a look at these collision volumes. It's pretty easy for us to add them, and I'm not sure like where they all are right now because we made some changes to that stuff in this pass where we're cleaning stuff up. And so we may actually want to just see where this stuff actually is. Let me, that's actually an entity.cbp. Let me just turn on drawing those. Just so we can tell, like, what are the collision volumes, because we don't actually know. So there they are. And if we hop out to where we were having this bug, just so we can look, let's see what happens, right? So in here, oh, well, aha. So I see what's happening there. It is that our room boundaries are wrong. Well, that was educational. I guess we can deal with that really easily. So where we add when we do the room generator, we add bounds for the room. And I guess I would say that probably shouldn't actually... That probably should be avoided when we check for... Like, we should fix it, but we also should probably turn it off. So if we do get room volume, this is not offset by a half, which it should be. That's really it, I think. In other words, this should have that offset baked into it, and it doesn't. Is about it. I'm not sure how we do this in this program. I assume offset. Yeah. So that will adjust the room to be on the new grid alignment where things are centered. And, you know, you can now see them in the right place. And presumably now, if we looked, we wouldn't have that overlapping problem. But again, we also probably just don't want rooms to be participating in that anyway, because rooms are not solid. They don't prevent you from placing things. They're just a boundary that lets you know where the room is, right? Okay, so let's see. So now that's still not right. It's close. Oh, duh. So I guess I forgot about the fact that it's actually not literally 0.5. It's the half of a tile. So let's take a look at the part where we get the volume for a tile. I think it's get total volume or whatever, right? So it's really this 0.5, you know, minus grid tile dim. That's the actual code we want. So this should be like this. And the only question is what to do about the Z there. And I guess I'm not sure. But maybe now this is aligned more properly. Let's hop out to a place where we were looking at before and see if it makes a difference. It might not. Might still be wrong, but let's take a look. So now hopefully those are lined up. Yeah, so those are now lined up exactly on the corners, which is what we want. So that's good. Yeah. And hey, we also have the light appears to be arranged properly now so that we would presumably not get that leaking. Let's see if we do or don't. The lights are all set to max brightness here, so they should create the situation. So we still have one there, right? That's still definitely the weird like leaking scenario. Oh, and you know what? We've only solved half the problem. So you can still leak out the top, right? So the collision volumes are not, like the ceilings are not in place. Which is a little bit odd because I mean, that makes sense because the apron doesn't create ceilings, but we created ceilings in rooms, actually. So it seems somewhat odd, does it not? Why are we not seeing those in the collision volumes? I thought we placed ceiling tiles, and in fact we saw them when we looked before. So what's going on here? Are those not collision volumes, or are they something else? Like, I don't recall how we added them, but we definitely had, yeah, like this. You know, add piece occluder. So I guess occluders are not the same. So do collision volumes get added as occluders, and so do occluder pieces? We're gonna have to unify this stuff. You can tell that code is in need of cleanup now that we know how everything works. All that's kind of ridiculous. So there is a code called push occluder, but it seems like it only happens if you have a piece type of occluder. Although maybe push cube would also do this. I'm not really sure. It doesn't look like it does. I mean, it looks like the only place that's called is from here, but we don't know if the lighting box push happens somewhere else as well. I'm not sure. But we know that, I mean, don't we? We know that we have occluders for the walls. So I guess the answer is the aprons don't have light occluders, or do they? Let's take a look at the actual apron generator. Does that push any occluders? It pushes a cube, but it doesn't push an occluder. I guess the tree has an occluder? Like, it doesn't look like it, right? So I'm kind of confused as to how we're actually getting light blocking from these things when we're not actually pushing occluders. It's very confusing. Because these are else ifs, so you can't have a flag that sets occluder otherwise. As far as I can see. The only thing that you can do is add piece occluder, right? And that happens where? So it happens when we're creating the room tiles, which we expect. There's the ceiling and the floor. There's one for the tree. So we haven't, by adding those back in, we haven't actually put any occluders in that region. So technically, actually, there are still no occluders there, which means we wouldn't expect that to stop the bug at all. So there's that, which I guess it doesn't. I mean, we did observe the bug, so I guess the answer is we should be able to, because we haven't actually changed it because we haven't added any occluders yet, we should be able to get this weird bug to happen again too. Yeah, like somehow. I don't quite remember there it was. Okay. So let's actually add the occluders in now, and we'll just rely on the fact that eventually we're going to come through and do a massive cleanup of the generation code as well. So it's okay that it's janky for now. Much like we're cleaning up the lighting code now, we will do a cleanup pass on everything in good time. So I'll go ahead and add an occluder to the apron generation because I was kind of under the mistaken impression that cubes automatically were occluders. They're not, apparently. So we want to do add piece occluders here that will be added for this entity. We don't really care much about trees, probably, at this point, because they're kind of just there for set dressing. So we probably want to do, actually, the way we were doing it in the generate room code, right? So I guess just, the whole volume. Whatever the ground tile volume is, I think is what we want. Yeah, I mean, I think it's literally this, right? I could be wrong about that, but... So we know we've got a ceiling occluder, and then we know we have, like, this other occluder here that's going to presumably be just this vol. And we know we want the ceiling one as well, which should just be exactly the same code, I think. The color part is like gonna be like a moon color. So I don't know, like... In a sense, this almost should just be like a light. It should be like moonlight, right? I would think. And so actually this is probably just an ambient light, a low amount of ambient light for the outside would be my guess. So like this code. So in the room gen, we would actually do like a lighting add here with an entity. The radius would be this. The offset would be this, I think. The lighting amount would be very low. And the color would be like some kind of moonlight color, right? So it would be like probably no red, probably a little green, probably a little blue. Something like that. Did I mess something up there? Oh, you're only allowed to have one radius. Okay, well, maybe this has to be more like this then. So put the radius in directly and the offset in directly like that. And then we have the emission and color. They come in here like so. I guess. And so I don't know, like, again, not sure about this, but let's give it a spin. Let's give it a little let's give it a little go. We can turn off collision volumes because they don't matter. As it turns out, it's only occluders that matter. So we can turn that off and not draw those. Flip back to the game here. There we go. And hop along. So not solved at all. Still having the same problem. And the question is why. Let's take a look at those actual spatial grid elements. Debug draw spatial grid. I'm going to turn that back on, turn off the drawing of the lighting spheres. We don't really need them. And let's just take a look at what we are drawing here. So you can see out in here, it does look like we've got floors and ceilings on here pretty well. So let's take a look at, if we can go back to the, like right here. Let's see if we can look at the actual raycast. So that's the ray direction. It's only iterating through this one piece, which is what you would expect. And it's hitting the ground. So we solved the problem, I think. Right? I mean, that is exactly preventing that cast. And I guess, you know, well, no. I mean, we saw this have the bug again, right? I mean, I'm quite sure I did. It's just not doing it right at this immediate frame. So, like, if I was to switch the ray around, is there any rhyme or reason to that? I mean, it seems pretty well cabined, right? So that seems pretty reasonable. Now, of course, it can convect the light around. I mean, it is able to get sort of, right, like to that area, okay. It's a little bit hard to see everything here because it's hard to see where each grid piece is actually. Let me see if I can provoke the bug where these guys actually light up again. For some reason I can't, which maybe, but I thought I saw them do that. Did I not really see that? Am I totally wrong? So that suggests we have a totally other problem as well, right? So here you can see a ray that actually is able to get in between, like, oh, because there's no ceiling on the outdoors area, apparently. Only on this part of the outdoors area. So is that true on the inside as well? You're not able to get, are you able to get outside of here as well? Because hopefully you can't. You know, you can't, right? Like it seems pretty well capped, and it does stop there. Right? Like it's hitting the wall, which is what we want. Let's double check a few other directions of cast from the same location just to see what happens, I guess. But that scans out pretty well. You know? So it seems like it's picking pretty reasonably there, but there isn't any ceiling over here. And so that does seem like a bug. And that probably means that the room generator needs to do that because it's not currently adding ceilings in all cases, right? And the ceilings are added pretty ad hoc. Like, we probably should add a lot fewer ceilings. Just like one ceiling tile that went over the whole thing would probably be sufficient, but at the moment it's not doing that. And that's fine. But if we look here, like, you can see, like, the not spec outdoors thing is totally not what we want. So probably you would need something like in here we would do a if spec outdoors, you do one thing, otherwise you do another, right? So where we add that occluder piece there, we would say probably want to like make this a little bit more systemic and just say this is the thing that gets added always, right? But let's just do this for now and see if this changes things for us. So that still seems really buggy to me. Like, there's still something going on with where if you happen to get right on the edge there, like, it's still able to do some kind of a really like erroneous cast for some reason that I'm not sure like what's going on, right? Like, something is busted there where it's able to hit something in a way that I don't understand. Like as if casting out from here produces a hit that's like somehow really illegitimate. Or something? Well, So, yeah, so like I'm not really sure what that is, but there's still a bug there for sure. And super peculiar. I wonder what would happen to, so like what happens if we don't add lights? So the only lights are just those ceiling lights. That's the only thing you can possibly hit. What actually happens in that case? We have some kind of like add standard lighting, right? So the standard lighting pattern thing here, if we just didn't do this, so if we if zero both of these out, there won't be any of those lights. And the reason I'm doing this is I just want to make sure, I want to confirm the fact that it's that you can hit these lights somehow. That's what's happening. I don't know if that's true or not, but I just want to make sure. I'm assuming it's true. So I do feel like something's a little off. So we thought, anyway, that we added in both cases a roof light that was the same lighting, right? But in this case, there's no visible lighting. In this case, there is. So why did this pick up lighting from its ceiling tiles and this did not? Are those ceiling tiles, did I add them incorrectly, right? Like something is weird there. What? Did I accidentally type that totally wrong? Oh wait, no I didn't. I put piece light in there. Ah. It is because these are in the wrong order. The outdoors one is the one that's supposed to get the light. And the indoors one is the one that's not supposed to get the light. Try that one more time. So it's definitely getting light now, which it wasn't before. So I think it's probably about right. Seems roughly right. I will say it's not as much light as it probably should be getting. I mean, in terms of like what we actually want to provide here for light. But I think we still have a bug because I don't think the light should be spreading when we turn on the other lights. I will say this is an interesting way of doing the lighting. We should just add ceiling tiles for lighting. Like, instead of the way the standard lighting pattern works, we should just make this always add. This should just be the light. You know what I mean? That seems like way better. And I don't know. Hard to say. Anyway, so if we turn back on the standard lighting pattern here, the question remains as to why we're getting the light leaking happening in the way that it's happening. It doesn't make solid sense to me. I'm gonna go ahead and turn these off. Because now, I mean, we know they're there, and really now we're just gonna have to look for like how the raycasting is doing the wrong thing, because I don't know. I will say, when we are not having the bug, it looks fantastic. I love the results, so that's good, but we still have some weird stuff happening here, and we don't know what it is. You can see we're going to have to expand that apron a little bit, because you can see as those lights come out, now that the lighting up is very fast, it updates so quickly that you see the error. And we want to leave it fast because we want to be able to move lights around and stuff. So we don't want to slow it down if we don't have to, right? So, you know. But I mean, man, that looks awesome. I mean, it's so good. It's just so good. So, like, yeah. definitely want to get these last few bugs out of here because it looks so good. And then you get that, and it's like, what is happening, right? And we have no idea. We still don't, even after solving a few obvious problems, we still don't really know what's causing that. And that is not a good place to be. You never want to not know what's causing a problem, right? Okay. I say. Uh, Alpha Lion Male. It is the code we wrote. Like it's our own engine. That's what we do here on the stream. And that's why we have a bug. That's why we have a bug, not some engine team has a bug, because we are the ones who wrote it. I will say that what is happening there, that might have something to do with it. If the aprons aren't really sealed, if the aprons aren't actually sealed, then we still could have a similar leaking problem. You could blame younger. That's true. That's true. I suppose technically we are using a graphics engine made by a previous version of ourselves, and it's their bug. Like, we didn't literally type in the bug today, right? So the bug is from several weeks ago, or possibly even years ago, because, you know, we only work on this a few hours a month on stream, and so, you know, this bug could have been from a fairly older version, a younger version of ourselves, right? Totally possible, and that we are simply not to blame. Why are people blaming us for this? You know, it's not our fault. So I do wonder. I'm curious. Does it have something to do with the fact that we don't always add a solid, like, blocking region? Yeah, everything in the game is 2D art except for, so, like, all of the art is 2D, but because we wanted to sort of have like a pseudo 3D look, the walls are made of actual cubes. But everything else, like, you know, like all of that stuff is 2D. Like, that's a 2D, it's a 2D character, right? As you can see, but what they're just locked to the view, so they kind of appear like they're sort of not 2D. I mean, they kind of still are obviously 2D if you look at them, right? So everything's 2D except for just the wall pieces. The walls are actual 3D because there didn't really seem to be any other way to do it. Like, I don't know really how you would do. If we had an idea to do it, we probably would have done it. because we are trying. The whole game's art is supposed to be 2D, but unfortunately, like, I just can't think of any way to really do walls in here that would be actually 2D and not 3D. So the walls are 3D because we couldn't think of any other way to do them, basically. All right, so what is this bug? Like, what is the deal? I just have to figure out what Chunky's deal is. I guess we don't actually know that this is a bug. We just don't know. Like, this might be that's just how much, because there's a lot of light in this area, maybe that is actually supposed to be that bright, but it also could be a bug. Like, we don't really know. We don't know that. That's hard to say. We do know that if we get, like, there, this is clearly some kind of a feedback bug, because it doesn't make much sense why standing here would produce that result, but standing here would produce that result. I don't know. Like, that feels probably just wrong. I mean, maybe it's not, but it kind of seems like it probably is. Celery Boy, we are going to make a game, but it's only because I feel obliged to do so. I'm not really a game designer, so, you know, the idea is to make an engine for a game, but in order to know if the engine works, you kind of have to have a game. So we will put game in the game, but it won't necessarily be very good. Right? Like, the game design might be very bad, because that's not, I don't actually know how to do that part. There is a good stream for that. Jonathan Blow does streams, and he's like, I mean, in my opinion, the best game designer that there is. Like, I've never seen a designer as good as he is. So you can go watch his streams and catch some game design from that when he happens to be streaming that. But I can't help you with that part. All right, so obviously we've got that is the bug. It only happens in very few places now, but it's definitely there. We can provoke it fairly reliably, and I do wonder a little bit if it has to do with when the lighting gets into a place where it can hit a uncapped region. Celery Boy, I agree that it could be educational to watch them and learn game design, but it's not going to be us, right? Because I'm not a game designer, and I'm not going to learn game design. Just simply putting game design into a game is not sufficient to become a good game designer, right? Like, you have to work a lot harder than that. So this really won't really won't happen on the stream. But we will make improvements to the engine. Like, we're going to clean up the engine. That's what we're doing right now, is we're cleaning up the lighting. Which now I think looks fantastic. I really love it. But we've got some bugs. You can see, like, there's some weird, right? Like, what's happening there? Although, actually, that's not actually... No, I take it back. That's not actually a bug. That's just because this apron is too tightly bound. If this were further out, like, that's because you're just seeing the wrapping of the lighting atlas. So... never mind about that. But, so I think it may still be just the Z. It might be. I don't know. Although that wouldn't explain this, would it? Because there's no Z leaking there. Is there? I don't think there is. I don't think there is. I could be wrong. But, like, that still feels wrong, and we know there's no Z leaking going on there, because you can see all around is completely black. Well, not black, but low light. So, I don't know. Do we think that's logical, or don't we? let's take a look at the casts. I mean, we inspected them in this area. They all looked pretty reasonable, though, is the thing. I don't know where there's a light cast, right? And, you know, it's picking the floor, which is exactly what you would expect it to pick. I mean, it's... So, I guess one problem that we have... can the ray... Oh, let me answer that question first. The part with can the ray escape through the door into nothingness? It can, but that's okay. So if the ray goes outside of the lighting atlas region, that shouldn't cause a problem. Now, maybe it does. Maybe we do have a bug, but that actually shouldn't cause a problem. The thing that was causing us the problem was that if the ray can cast in Z outside of the Z bounds and get further into the actual valid part of the lighting atlas, that was our actual problem, right? So if it can, so if it casts out this way, we wouldn't really expect any problems because all of the light out here, there's nothing out here for it to sample. It's the lighting atlas is bounded by this cyan. There's nothing to sample outside the cyan. You just get what's at the edge of the thing, which is fine. That's a totally fine place to sample from. What was happening before that was illegal was basically like you'd be here, you'd cast a ray upwards, and it wouldn't hit anything, so it would just keep stepping and stepping and stepping and stepping, and it would pull light from way the heck somewhere else, right? Or tunnel through a wall, like it would just keep casting and end up like sampling from over here or something, right? That was still inside the light atlas, and it was pulling light from some place it shouldn't have been allowed to pull it, right? If that makes sense. So what I'm thinking as well, though, like as another thing, can't sample from the wrapped region. It doesn't sample from the wrapped region. Just to be clear, what that is just the renderer. So when it goes to render, it just like when we set these bounds, you should never be able to see the cyan boundary. That's just because we have them sized wrong. So we need to push that sizing out a little bit, and then we're good. All you're seeing here is just it happens to, if you use a debug camera and you view outside where the atlas is, it's just going to wrap, right? So that doesn't really matter. And Feltcraft, I'm inclined to agree with you. What I was about to say, at least I think, agrees with you. And let me say it, and you can tell me if it does. So, I also, don't know how that... We saw, how is that getting brighter in there, right? That suggests to me that we're still somehow able to escape that area, sampling-wise, right? Which we shouldn't really be able to do. Let's double check that. But let me say what it's going to say first. What it's going to say first is when we do a sample from the light atlas. So if we hit a light, you are automatically getting the inverse square law for that light, right? When we hit a non-lit region, so something that just has indirect lighting, and we sample from that, no matter where we sample, we're going to get whatever that color is, and we're not inverse square lawing that. Is that somehow wrong? I mean, I don't think it is. At the moment, it's not allowed to do that on grid walk iteration out, is it? I mean, it basically it sets the hit ref color to nothing. I guess we should change the hit emission to nothing as well. I think that maybe we should do as well. Let's just see. I just want to make sure that it's not something stupid. And like, what's that? So we have a bug on every other boundary, right? Because what would be causing that to change? Could it really be an accurate cast that is causing that? I doubt it. I mean, I could invent an explanation, but that seems wrong. Doesn't it? Like, it seems like that should not have happened. So it seems like we still have some kind of an error. Does this happen with pure white, pure red lights? It happens with, well, currently the lights are pure white, aren't they? Oh, no, they're not. Here's a pure white light. The ceiling tiles outside are not pure white, though. And, you know, we don't get the same kind of bleed, but the light isn't as bright. If we change it so that the light is... in order to... I'd have to add a little more energy to make it... because they'd have to be all 7s. I could make them all 6s. Or 6.5s or something. But this will now be like a brighter white light. I mean, same. We wouldn't expect the channels to have anything to do with it. I mean, you know, if we had some kind of a summation bug. If you make the lights dim enough, then you don't get this kind of overbrighting problem, but I'm not sure. I guess I don't really understand why. Again, still kind of just confused as to what exactly the bug is. You know, if we knew what it was, we'd fix it, right? So it's weird. There's like some boundary where we go below the amount that will do this contamination for whatever reason, it looks like. Like, that's just not enough. Somehow. You know, we don't know why, but that's just not enough to end up leading to the feedback that we see. I guess. Right? Because the entire system is now apparently stable, and like I can't get any of these rooms to evince the bug. The heck is that? It's like some weird like noise that I saw down below. So there is some kind of value sensitivity here, and I'm not sure I know what it is. It might just be that, I don't have a solid explanation. Because you would think that it would either be stable or not stable, and that the total brightness wouldn't matter to the stability, right? Like, you should just see the same thing. And it seems like maybe we have some kind of clamping happening somewhere where if you're below a certain threshold, then it takes energy out of the system in some way or something. I don't know. The reason that the light in the bottom left is brighter than the others, I think, um, well, no. You know what? I'm not going to say. I do not know. It does seem weird. It seems pretty weird. I don't know if the height or something. Is there something else randomized about lights? I don't see anything yet. So I would assume, I could be wrong, I would assume that that is also a bug, meaning or related to the bug. The fact that that is brighter seems wrong. Because simply being in a corner obviously doesn't do it, because like that's also a corner. And that's not it. We could look at what the casting looks like in that region and see. I don't know if there's any particular thing that we can find out from that, unfortunately, but let's check. So if we just move our casting debug back one and down one, that would be the place that we're trying to pick up, right? It's right on the light source. Like this big white thing up here is the giant light source that's sitting in that area, you know. And the cast looks, like what I would probably expect. I don't know, what is the purple line supposed to be? Do we remember what that is? I don't remember what the purple line is. Oh, the purple line is like the face normal of the octahedral map. It's like where the face of the octahedral map is pointing, right? And I mean, you can see them it's just hitting the light source there. So there's nothing particularly odd about the casting that I can see. So I don't know. I'm not sure why we're getting more of that. Like, for example, I would assume you would think that if there's a light in that corner. Now, maybe there's not a light in that corner. Actually, let's take a look. There is. I mean, there's a light in that corner. So the fact that there's a light in that corner, it's a little bit odd. I'm not sure why we don't see the same kind of a brightness there, right? Because again, like you would expect, this is like the same kind of geometry basically, and the same. Yeah. Now there are some. I mean, it's possible that it has something to do with the fact that the sampling sphere is like biased, possibly. So, you're correct. The light sphere is larger. It is larger than one tile, I think. Maybe the problem is that it's centered wrong. Like the light sphere is like further in on this side or something like that. That would explain perhaps why it would be brighter in this corner than in other corners. But I don't know. Other than that, I can't think of a lot of reason. We could draw lights pretty easily. So if we just want to know a little bit more about that, that's probably not particularly difficult. We could just say like, all right, show us like where lights, specifically lights, are. So here's all the lights. I mean, they look totally normal. I don't see anything weird there. I guess I would say I don't understand, though, why is it pushing? It looks like it's pushing down a different size than the actual light is supposed to be. Wouldn't you say? So here's the push light call. You can see it adding a radius here. Is this supposed to be, is this off? This might be supposed to be like a half, like a 1/2 thing. Yeah, I mean, because this is a rect center dim, not a rect center half dim. So I guess I don't know. I guess I don't know which one this is supposed to be. This says radius, and so this should probably be 2 times that, right? And is that what we called it everywhere? Yeah, we called it a radius. So I think that's fine. I think this code is just wrong. So that's supposed to be 2 because this is a radius, right? Which means that actually, it's that is where the lights actually are. So, you know, and I guess I would also say, you know, looking at how they're placed, I have no idea why you would end up with more collection in this corner. Like, I don't know why that light would, in theory, be more than any of these other ones. It doesn't make a whole lot of sense. It could obviously be luck. Like, we could be seeing, like, sampling bias here. And we could try to prevent that by doing some kind of else. Oh, what? There was a to-do in calc base P for offset. Let me take a look. Yeah, it could be that it's picking up light through the wall somehow, but I'm not sure. We didn't see any evidence of that when we looked at the casting here. So, I don't know. Maybe we should have a way to turn off lights, like kind of click on them and like take them out of the solve so we could see if which lights are affecting which thing. That seems like that would be kind of useful, but yeah, but I don't know. So let me look at the to-do that you're talking about. So you said calc base offset, calc base P for offset. Let me take a look at that. That doesn't really matter. That's just how the lights are arranged. So that's actually fine. I don't think that matters. So one thing that we haven't considered is it possible that two lights are getting added on top of each other in that area? Although that wouldn't affect anything, so I guess it doesn't matter. But so, yeah, I'm not sure. There's still some definite weirdness that we have to track down. It's also kind of odd that some rooms seem very stable and some rooms seem unstable. And that part is confusing. You would expect there to be a little bit of instability everywhere. If it was like a bug, like if it was a fairly obvious thing we did wrong. So it kind of has to be maybe slightly more subtle. This part, like, why? You can, like, that doesn't make any sense. Why is that getting brighter? If anything, it should get darker because there's less lights, right? Like, these lights are going to fall out of the solution about here. Why is it brighter there for a second? There's something wrong where we're able to, like, somehow we're adding, like, to the wrong atlas, or something weird is happening. So what's happening here is, like, we're getting some residual brightness sort of like in this region, right? And so if we look at, like, this cast here, so, I mean, in theory, though, that should be fine, because this is just this will clamp to the light atlas, so your sample point would just be here, I think. Maybe I'm very wrong about that, but the light atlas sampling is clamped in the actual sampler. Let's keep looking though. So, yeah, I mean, I don't think that's a problem because it should just clamp back to here. I don't know why that would really be causing us any problems. Also, that's going to be a T terminate, which in theory shouldn't sample. Like, so if we look at the lighting code in grid raycast, we don't actually, like, not only would we not think that was a problem, but we're nuking those, right? Because hit ref color and hit emission, this is the case that's being hit there, spatial grid node terminator. So when we hit that, we're actually going to produce 0, right? Maybe that's wrong, but let's take a look at what happens if we set that, right? Because we'd fall out of this case. And I guess something hit would be, this is what happens in the case where you get something hit, right? If you don't get something hit, then you do this. And so both of those things would be fine. We'd end up out here. We have it all. We would end up out here doing a bunch of work and coming down eventually. This is all the sampling and all that crap. And we would eventually say that we were going to take the ray weight times the transmission level and the hit ref color. The transmission level is just the reflect level versus the emission level. So, like, it seems like as long as this is 0... I mean, we shouldn't have even had to have set both of them. As long as hit ref color is set to 0, it should not be able to accumulate anything. It's just 0. So those are actually going to just be 0. And I suppose one thing we could do here is we could draw this with the color that we actually found as well. Like, we could put hit ref color as the thing that we draw just to be sure. But, you know, this just isn't going to contribute. So I just fundamentally do not know where we're getting any of this light from. Like, how are we getting more light in this area? Because we can, let's take a look while we're in this exact place where we see this bug. Let's look at the in the lighting code. Let's look at the debug draw octahedral values as well. So if we turn those on, where is it claiming that the light is coming from? So it's claiming that the light is coming from here, right? It's claiming that we're getting that light by casting through the wall. And so even though we can't actually find an example of us casting through the wall, we are nonetheless casting through the wall somehow. This one seems brightest, so let's look at that one. Like, we need to, like, show me all the casts in just this big... I don't know, man. I don't know how it's like it's claiming it's getting the light from there, but we actually can look at the light values and we don't seem to get the light from there. Maybe, is it possible that actually what's happening is that our sampler is messed up? So it's actually, maybe, okay. Maybe the problem is that our sampler is actually sampling offset from where we actually hit. How about that for a stupid idea? So in this like ridiculous code here, where we're taking the, you know, here's the total bounds, like we're offsetting it from there, whatever, right? We do our, our sampling code, this kind of nonsense. Is it possible that somehow this code, when it goes to get the atlas out of it, that is wrong? So I guess the first question I would have is, why the heck is the spatial grid involved in this computation? So maybe this code is just wrong. Did we just never realize that... Did we just never realize that we had this code wrong when we switched to these being staggered? Because if you think about it, the spatial grid that should not be involved anymore. Because the spatial grid is not aligned to the atlas at all. It's a completely different grid. Right? And it's very possible that when we wrote this code, originally they were the same. And because it's like super optimized code, like all of our stuff is gone, like things we would have normally done to like assert or check, is very hard to do because SIMD, one of the super crappy things about the way you have to program nowadays is when you actually go to optimize something SIMD-wise, you get screwed. Everything becomes very hard to assert and debug and all these other sorts of things. But that could be our, well, not exactly our problem, but like in that case that we just saw, that could be the problem. Hold on a second. Let's just take a look at this. So let's reproduce that. That would make sense. So that would totally fit with why it gets wrong as you stagger out, right? As you go on half boundaries, this code is wrong. Because it's not using the correct thing. So I'm going to go ahead and say that that's our problem. It's not probably our only problem, but that is a big part of the bug. Yeah, this is just wrong. So everything after this is probably correct because everything else is done relative to the atlas, like it should be. But this is totally wrong because this is not the bounds of the atlas, and this is not the dimensions of the cell. Right? Okay. I think I'm definitely right about that. So, taking a look at the lighting solution, the grid that we actually want is the atlas grid. Why do we just have something called grid when we have two grids is a very good question. Grid. What the heck is grid? Maybe we picked the right grid, there, and I'm totally wrong. And if that's the case, then oh well. We did not find... Where is it? All right, I lied. So grid actually is Atlas grid. So we're okay there. Or at least I think we are, but we should make sure. Meanwhile, I'm going to change this to Atlas grid so that I don't have this confusion again. I'm still kind of weirded out by this, though, so I'm not sure I really believe it yet. I still think maybe this code is slightly wrong. In fact, I know it's slightly wrong. Because look at how this is being done. Yeah. This is definitely wrong. It's still wrong. So if you look at how we're choosing where we're going to sample, you can see that the corners of this thing are based on, like, do we know that this grid, how did we actually position this grid exactly? Okay. Not exactly. So let's take a look at the literal alignment of the, I mean, like, so you can see this is just, we're confused. We have confusion baked into our system. This thing, whatever the heck this is supposed to be, right? This cyan region. So if we look at, let's just work it forwards, and because I'm pretty sure now I'm right. I mean, I'm right that there's something off-center about the way this is working. So if we look at what is actually drawing that code, it is that cyan boundary is like the lighting bounds, which I don't remember who draws those, so we should double check. It might be in an update lighting, actually. Let me just see. Yeah. So this is drawing, that's this code. There's the total bounds of the spatial grid being drawn in green. And there's the hot voxel rect being drawn in cyan, right? And that hot voxel rect, I don't know why that got offset, is the Atlas grid total bounds. And so you can kind of immediately see what we screwed up, right? Supposedly, our light samples are being taken from, like, these points, right? But the actual location is, like, when we sample, we're sampling as if they're here, right? So we're like sampling in one place, we're taking samples from, or casting rays from a location and writing back a result for that Atlas point, but then we're sampling from it as if it was in a totally other place, right? So this square, these samples are as if they were out here, which is totally not where we actually took them from. So the ray cast doesn't line up. Where we are casting the rays is not related to where we actually then pretend those light values are. You feel me, dog? So that's the problem. Like, period. So we need to go resolve that. We need to go be very meticulous and make sure that everybody has their ducks in a row about where the samples are taken versus where the samples are written, right? So I vote for a quick break. We've been streaming for 3.5 hours. Let's do a quick break, and we're going to come back and do that, because that is almost certainly, at the very least, what's causing this brightening and that weird, remember I said like that should not be flickering like that? That is almost certainly what's happening there. Is as you move it around, the alignment of the grid versus the samples is moving. And so sometimes you end up sampling on one side of a wall and recording the results on the other side of the wall, right? Or things like that. That's going to be why you're getting that happening. I don't know if this has anything to do with our light leak problem, so I can't promise it'll solve that. But this is a big problem, so let's solve this first, and then we can maybe go back to looking at the light leak problem. All right, break time. If you don't, I mean, what else do you want me to do? I don't know what you want me to do for a break. You want this instead? I mean, that's your other option right now. Cody, oh yeah, Cody, you want Cody to do it? Do you want a product placement for a uh for a VPN? I didn't realize I like someone said the Will Smith approaching thing. I didn't know what the Academy actually was. I think I was under the impression, because like he resigned from the Academy, right? And maybe they would have kicked him out, you know, because of the incident or whatever. I think I thought the Academy Awards were like a union award thing. Like, you know how there's the Screen Actors Guild, or like the Writers Guild Association of America, or Writers Guild of America, or whatever it is, WGA, the SAG and WGA, right? I think I thought that it was the award was like union, like the union was like union members voted or something. I think that's what I thought. Like I thought like, oh yeah, the screenplay, like the WGA members vote on best screenplay or something. That's what I thought, right? But actually, after this whole incident, I looked it up and it's like, that's not what the Academy is. The Academy is literally just like a separate organization for them to like glad hand each other. Like there's nothing, it's not a real thing. Like the Academy Awards, the Academy of Motion Picture Arts, Science, or whatever is literally just a completely separate organization for giving themselves awards, I guess. It's not actually one of the unions. I thought I'm so weirded out by the Academy. It's like it's literally just a separate glad handing organization for like giving themselves awards. Like it sounds very much like the Game Awards in that sense. Only it's somehow been legitimated. So like I think we should start our own organization, like here on Handmade Hero, called the Handmade Hero Awards, and shockingly, all of the awards will go to Handmade Hero. Anyway, I thought that was pretty funny. I didn't realize that. So like, saying you won Best Picture means that all of the people who decided they wanted to be part of an organization that gives Best Picture voted to give you Best Picture. It's so interestingly self-selecting. I don't know if we've never had anyone slap anyone else on Handmade Hero. But that's probably because it's just me. And I'm not probably going to slap myself. Like, I'd be like, oh, like, you know, I don't know. I mean, really, if we wanted to do something like the Game Awards, from what I've seen, the Game Awards are like just a giant advertisement. Like, no one cares about the awards. They're just there to advertise new games or whatever. So we could also go that route instead, where like Handmade Hero Awards are literally just me like pimping the stream for an hour, right? It's just like talking about exciting things we're going to do on the stream later. So like even though it's an award show which is supposed to be for things that already happened, instead mostly all we talk about is things that are going to happen someday. Well, speaking of things that are going to happen someday, let's make one of those things gonna happen someday is us fixing this stupid problem. Okay. So, let's start with me being really freaking confused about the sampling. So somehow, when we sample the rays from one of these places, I guess it's because we're calling get cell center P. Must be the reason for that, right? I mean, I guess not really. That's just the spatial grid. So it's really actually the place outside of this. It's the part that's actually telling us what location we want to cast from. So when we call, it's actually when we call grid raycast, the call site, this part here, that's doing the full cast, that like Vox Center P, that's actually what's creating this situation, right? Ryan, I like that. Yes. Yes. Exactly. So, that cell center P is total horse poop and probably has been for a while. Right? By the way, I'm eating peanut butter pretzels from Costco. Basically, Costco, I need to get a Costco sponsorship from the stream because a lot of the things I eat on the stream are from Costco. But I'm not getting paid. Where's my Costco sponsorship money? That's what I want to know. Like, how come we don't have little Costco banner and stuff, right? Where's those sweet Costco monies? I don't think I've ever seen a streamer sponsored by Costco. So, probably not going to make that work. But, you know, I'm just saying. Yeah, you should talk to Mr. Costco. Let's get Mr. Costco on the phone. Let's make that happen. Okay. So, this is just a giant horse poop pile because we're casting out of the center of a grid square, but we don't write the sample values back to the center of the grid square. We write them back to the corner of the grid square. So what sense does that make? Right? Not very much. Not very much at all. So, I mean, we can start by asking the question of why does that call even exist? Why would we ever get the center of an atlas grid? I mean, I guess because we want that for other reasons. But it's just garbage. Like, I don't see the point of it. So, if I may, I think we need to start by doing something like, let's not do that, and let's just get the min corner. You know what I'm saying to you? Let's go over here to the Mr. Light Atlas Sun, and let's figure out if there's a reason why we're calling this. Oh, that's the wrong atlas. We are looking actually for the spatial grid. So in here, like, we want the cell bounds, and we want to use the minimum of the cell bounds because that's where we're actually writing that sample, right? So let's start by doing something like this, just to see if we can slowly work our way, because now this will move all our sample points to the wrong place, and then we'll offset the grid to being in the correct place. Hopefully, maybe, I don't know. So, you know, we'll kind of go as we go. So we have a second problem, which is that the thing that draws them is also going to be calling that get center. So this box center P thing. I should also, we should just call this like cast from P, because it's not going to be any particular box's center anymore. And then if we do draw, you know what's kind of funny? I should have just changed where we draw them and then said it was correct, right? That's like the US government solution to the problem. Instead of actually solving the problem, just try to hide, conceal, or change the numbers or redact the like pages to make it seem like everything was fine, and then you don't actually solve the problem. That's what we should have done. But, you know, silly me, I went in here to try to actually fix the problem. What am I thinking? Anyway, in debug draw octahedral values, this is this part here. The center P, that should go away. Center P instead should be like cast from P, and that should be the corner of the cell, right? I assume. That's my story, and I'm sticking to it. I don't care what you think. I'm going with that narrative. Okay. So, in theory, now we're casting from those locations. I don't actually know that that's true. I also don't know what the heck this is. I guess that's just the thing that says that there was something there, or something. But we need this to be rect mindim, if we're trying to do... Actually, no, that's not true. So, because we are trying to say, like, this is a little rectangle centered around the thing that's casting, I guess. I don't know what the point of that thing is. We don't really need that, but, because we can see where it is just fine. So that, those little red squares are not particularly valuable to anybody, I don't think. But, you know, whatever. Anyway, now we can see what's actually happening. So this is the truth of the matter. This is the sad truth of it all, right? And the reason for this is because, again, like, this voxel, you have to remember, is we can only interpolate between points that we actually have. So this cell, it doesn't really count for anything, and we need to actually clamp to just the earlier value. Like, we're kind of like, we have a one-off problem here, right? Where we want the number of, we want the actual thing to stop one before the final number, because we have to be able to sample from everywhere in it. Now, I should mention that even now, like, we're going to get some pretty bad lighting artifacts because, like, half the crap is, like, in the floor and other things like that. So, you know, that's not good. But we should already at this point have gotten potentially fixing the... Oh, wow, okay. Well, that is... I don't know what that's from, but that's pretty good. I was going to say, we should be able to fix the light leaking from the one part that we had here, but, man, we've got other issues. That's fine. Like I said before, you know, we want to fix this all the way. maybe this will help. I didn't think this was going to, but maybe this will help us solve our light leaking problem, because if we can make that happen like that pronounced, hopefully that would help us solve it. I don't know, though. That may be wishful thinking. You can also see some really strange stuff already. Like, how is all of this bright when the black, like, the black sample spheres would say that there's no light in that area, right? So, anyway. So pushing forwards, we kind of have to finish getting all the rest of this stuff working. I want to finish my pretzels first, though. So, at this point, our samples are definitely in the wrong place. They're now properly aligned with the atlas, sort of, but also not, because we now sort of also have to think about the fact that we want the actual bounds of the voxel to clamp out before the end of the voxel, right? And we're gonna have to look to see like how we actually create some of these things, because like I said, I don't remember. It's been so long since I wrote this code, but you can see on here where we're doing the like make voxel grid and this sort of thing. We are going to use, when we're making these grid pieces, we're going to be using like information about how many things we have inside the voxel. So you can sort of see here how the spec atlas, I mean, they're fixed sizes, right? So the spec atlas and the diffuse atlas are both whatever this atlas cell count is. And you can see that when we create the atlas grid, we end up making a voxel grid with, you know, the whatever the atlas cell count is in it. My thinking there is that that really should have been stepped back one, right? Because each grid square is you can only interpolate within the cube, and you can't. You need to end. The size of the voxel is going to be one less than the number of sample points in the atlas in each dimension. So if, you know, the x dimension of our atlas has 10 samples in it, then the atlas grid should only have 9 cells, because you need one at the end in order to interpolate all the way out to the outside of the atlas, right? So the voxel dimension for the spec atlas, like, did we factor that in? That's, I guess, what I'm wondering. And I don't know, because it's been so long since we did it. So if we look at, like, make light atlas, where we have, like, the voxel dim, how do those things line up? And I'm not sure. I mean, it looks to me like they basically don't. Yeah, so I mean, I think I'm just right about this. I don't know. I think essentially what you want here is when you look at the Atlas cell count, you have to subtract 1 from it when you make the like corresponding spatial grid. That's just what happens, right? Um, and I don't mean this spatial cell count. I mean literally the grid that corresponds to the Atlas. Like, this is not correct. So at the very least, the Atlas grid here, I'm going to say we need to start by subtracting 1 in all 3 dimensions when we determine how big this thing actually is. And the Vox cell dim is fine. That is what it is. We don't care about that part at all, I don't think. But at a bare minimum, like, we need this thing to be exactly the bounds, which now you can see, like, at least it's starting to line up the way that I wanted it to, right? So whenever we are clamping something, whenever we are going to, like, sample and we clamp, it clamps back down into something that is the correct spatial region. Now, what the heck is happening here, I have no idea. So that's going to be a fun little treat. This is all just so freaking weird. Like, I have no idea. I have no idea what that is about. So we're not going to pretend that we know what that's about yet. But first, like I said, I want to solve one problem at a time. So the first thing we want to do is figure out, okay, if we assume that this is now bounded properly, then the next step is to actually make sure that the bounds line up with something that would work. So we want to shift the bounds so that they are back in the center of, they're back like roughly centered. So when we align this particular grid and decide where it's actually going to be, we want the once we make this voxel grid with, the cell dim and all that stuff, we want its base, like wherever it's actually placed, we want that to be offset in some particular way, right? And so at the moment, this set min corner nonsense, right? That wants to be offset by 1/2 the fundamental grid size, right? So instead of Atlas min corner here being like this offset here, we actually, it looks like we sort of already kept it at centers, so this actually wants to not happen. The Z might need to change. Hi, voice. So this might need to occur or something like that. We'll see in a second. But we need to remove that sort of offset on X and Y, because that should actually be centered now in theory. Okay, so I think that's about right. I can't quite tell. It's too high. Definitely too high. Okay, so I lied. Maybe it. Oh, So let's turn that off for 1 second. And let's see where that is roughly at. Okay. That seems pretty good, but still probably a little bit too low. So I'm gonna say shift it up a little bit. I don't know if half the fundamental dimension is the right amount, but it might be. That looks better. Yeah. So I think that's about right. You know, roughly. Okay. So the overall size of the lighting is it correct? Is it not correct? I'm not sure how the alignment is overall. It looks like it's skewed a little bit that way, but not in a way that would necessarily concern us because it's 2 versus 1. You're always going to have a little bit of that. So that's probably fine. So I would say this looks about right on alignment. I'm gonna say that's roughly correct. Yeah, you know, within reason. So I think those are now aligned properly. I don't know exactly how when we send down our lighting values, we send them down. So we may have to update that a little bit. So here when we do, push lighting render values, I don't really know what we send down for our actual textures here. Doesn't look. It looks like we just used the Atlas Grid total bounds, which seems fine. That's the hot voxel rect minimum and the inv hot dim. That seems fine. For sampling, probably, possibly. Yeah, I think that's about right. Yeah. But of course, we also sort of have another problem here, which is that anything that is outside in Z wants to clamp back in Z. And I don't know if we have anything like that in the shader. So we kind of need to first make sure that the shader itself, when it does this lookup, the shader is going to have to do something about that. Right, like it's got to actually make sure that it keeps you bounded inside the voxel, which I don't know if it actually does or even tries to do. So that's a good question. What happens? What happens there? Does anyone know? So we should probably we never were able to get a 4-coder that actually could show these properly, so we probably should move these out into separate files now because it's just too hard to read them. I had hoped at some point that you'd be able to just include your shader code directly in your C code, but that didn't happen. So I suppose I could fix it now. I have access to the 4-coder source. I should probably just go fix this myself. Because I can't imagine it's that hard. All it has to do is not change to a string parser, and just leave itself doing regular parsing, and this would work. So maybe we can fix that someday. Anyway, if we look in here, we're setting the vox minimum corner and the cell dimension. What inv total dim means? Is that... Okay, so it's just the inverse of the complete dimension of the voxel, so that seems fine. So at some point, we're going to compute which cell we're looking into. And it looks like this is, the code that does that, right? There's the sample lighting. And then up in here, you kind of have, okay, we're sampling from this voxel offsetted by this, this cell index versus, offset by that cell index. So that implies to me that we first, in here, we must have computed what our base voxel lookup was. And you can see it's got an 0.5 offset there. So I think this has kind of been wrong the entire time. Basically, we had lighting values that we were offsetting by 0.5, which was kind of correct in terms of their placement, but we were never casting from that location, right? And I guess originally that was okay because we had so many Z samples that we actually just left it in place and we didn't need to shift it. But now that we only have 2 Z samples, they both have to be inside, which means that you actually have to cast from where you think you're casting from. So yeah, this is kind of confusing. But I think this probably was slightly wrong for quite some time in a way. But anyway. So when we come in here, assuming that now our voxel is always aligned, we don't really have to shift anything because the placement of you in the world should just be correct, right? So that should not be required. When you do the floor value, you'll just get the correct corner, and this will give you the correct interpolant. And the only difference here is we want this to be clamped, right? So we don't want this to go too high or too low because you'll just end up sampling weird places in the texture. So that's easier said than done in X and Y because we don't actually have a maximum X and Y here. Like that is not in the actual thing, right? So if we look at the lighting sample, which is this code here, when we do the voxi plus devoxi, that needs to get clamped. And I think that's basically it. I don't really remember how GLSL works at all. But I assume it's not that complicated to clamp something. So like, for example, we have like clamp 01 here. We made some of these macros. They're this garbage right here. So I assume that if I were to do a clamp, I could just clamp to 0 and something else, right? Like if I said, all right, the I value is actually a clamp of this voxi plus devoxi nonsense. And the minimum value is just 0, 0, 0, which I think you can do this way in GLSL. And this value is just like the maximum, like it's like the lighting, the maximum lighting voxel dimension, which is this thing. And hey, look, it's already a vector even. So I think that would just fix it for us, right? So in theory, that should clamp things. Who knows? But like in theory, that would clamp all of our lookups now so that they aren't fetching out into no man's land. And I guess, like, I don't know, but I think that, yeah, I mean, that's why it's not black now like it was before, right? So, okay, still a lot of weirdness, though. Like, wow, like, what is happening, right? So, but getting closer. So we've fixed the alignment, I think, in the shader to now be clamping, and in theory, I think it should be clamped to the correct places. What I should do now, I want to do like a little bit more cleanup work first, but what we'll do pretty soon after is I'll seed this with known values. So I'll just put like RGB, RGB, RGB in it, not actually compute any lighting. And then verify that I'm sampling correctly, you know what I'm saying? In the actual shader. Because, you know, now that we've made fairly substantial changes here, it's going to be kind of weird. Like, we're definitely going to be in a position where we don't have, like, you know, we won't know where our stupid bugs are, right? So we have to start to feed some structured art through it to, like, secure one system at a time. But before we do that, I want to go fix other problems with the spatial alignment of the atlas, which is to say that when we are doing our sampling in here now, I want to make sure that this makes some sense, because I don't know that this makes any sense either. So in here where we're doing our sampling now, we know that we're loading the atlas grid, inverse cell dimension, and total bounds in here, which is good. That's what we want. but I don't know about the rest of the code. So how does the rest of this stuff work? Let's look. So the voxel dimensions for the diffuse atlas are loaded here. The floor of the F chord, that all looks right. So we're extracting the minimum. We're multiplying by the inverse dimension. So that tells us where we are in the grid. We are taking the stride of the atlas and the dimension of the atlas for sampling purposes, which is fine. We are looking at the max sample location, which is also fine. We're clamping the B chord to the max value and the minimum value. That seems right to me. I don't know, that seems right. That all seems like totally reasonable. So I could be very wrong about that, but that all seems like pretty reasonable. Like it's just a trilinear blend. It's interesting that we say this because we did kind of weld it in, right? Yeah, so we don't actually need to do, yeah. Anyway. So I don't see any real weirdness there. That all seems like fairly sane to me. Mostly. Mostly. Now, I don't actually know, and I would like to check, that where we are raycasting from makes any sense at the immediate moment. That I'm not sure about, but it shouldn't be too hard to figure that out. Why am I not... Why is my raycast not moving? Look at that. It's like, I'm not going to move. What's up with that? Why am I like, no, you can't move? That's bizarre, isn't it? Are those clamping to something weird? I don't see quite why, but it's fine. So the Atlas grid cell count is actually wrong now because we fixed that part. So this can actually do a debug pick from everywhere in it. But that shouldn't really have been the problem because that's, yeah, that, I don't know why that clamp would have been not working in the other dimensions, but I guess it's not. Yeah, like why is that busted? It's like, no, you are not allowed to move. Doesn't that seem kind of odd? Like, what's the deal with that? I mean, one assumes that's the Atlas index's clamping happening, but maybe it's not. Like, if I get rid of the clamping, is it still broken? Okay, that's just mysterious. So we've entered like full nonsense land where we have no idea what's going on, obviously. So what's the problem here? Why is our debug, why is this not allowed to edit? Is there something we don't know? That we're supposed to know? Aha. Yes, there is. So this has to actually work, and it's not going to now. So this was getting reset every time, which is not good. So what we want to do here is we want to actually predetermine, like we want to pre-make that number, this right here. So we want to like v3 atlas grid cell count. We want the atlas grid, you know, to have been computed ahead of time. And we want the atlas grid cell count to be checked here. We want to say like, okay, if the atlas grid cell count is not equal to what we have it set to, then we will do our little fancy dance. That was weird, to say the least. Okay. So hopefully that resolves our problem, and it did. I can put the clamp back in now. It looks like I already had, so that's fine. But now let's get back to the question at hand, which is, okay, so what are we actually seeing here when we do these raycasts? Because, you know, who knows? We don't really know. Let's take a look at one of them to see what the heck is happening, because we don't have any idea. So, I don't actually see where this is casting from. Oh, it's right there. That's not really that useful to me. Let's try like there. Maybe. Yeah, that is not correct at all. Like, so we're casting in a totally not correct location, apparently, or something. It's just considering itself to have always hit, right? Let's look at the Z one down. I mean, those all seem fine. I don't see anything weird there. Seems fine. No, so we're definitely in a weird place. So we're offset somehow. Like, that's not hitting the ceiling. Is it? Oh, wait, no, it is. No, it is. That's the light source. So this one was also probably inside a light source. Ah, but you know why it was casting from inside a light source? Because full cast is probably using the wrong location now as well. One assumes. So in here, ray origin. So that should have fixed it. So I'm not really sure. Atlas to spatial grid index offset. I wonder if that's wrong. Like, I wonder if that initial grid index is wrong. Half Atlas index. Okay, that makes sense. That, on the other hand... I don't know if it does. So my first question would be, can we just not do this anymore? So does anyone else use this? Because if not, like, it seems like pretty, with all of this work that we're doing during raycasting, it seems pretty inexpensive to just say, look, get the initial grid index by actually mapping it into the voxel, so I don't have to care if these two things are aligned, right? In fact, now I really just don't even want them to have to be aligned because there's no reason why they should have to be aligned. And so I think we want to get rid of that entirely. Like, I think we want to get rid of this concept completely. We want to just map the thing into the spatial grid just full on, right? So we take whatever the light probe P is, and we just map that in. I don't actually know what the code would be, but this, I guess. And I assume we need it to be clamped as well. I mean, although it always should be, so that's actually, if you could just assert that it's inbounds, actually. So I guess you would do something more like, all right, half Atlas index is out of here. Goodbye. Initial grid I is get index for P for whatever the spatial grid is, and whatever the light probe position is, figure it out. And then here in initial grid index, we're just making a flat index from whatever that was. I'm going to assert that it's inbounds because, who knows, maybe we screwed something up and it's not. But it should always be, because we only cast from inside the spatial partition. We never cast from outside. And so, flat index from is a U32. So let's cast that down. Although I don't know why, because it doesn't have to be a flat index anymore in that way. It can just be 32-bit. So actually, switch all this to 32-bit is now fine, because the only reason there was 16-bit is because previously we had walk tables. We don't have walk tables anymore because we optimized all that out. So, you know, that's all fine. Okay, so in theory now we should at least be starting from the correct grid location. You know, although I guess, you know, before I even look at anything, I should finish the rest of this, though. So now we should be starting from the correct grid location because we're actually mapping it in here, and we can get rid of that half atlas. We don't really need atlas to spatial grid index offset. Like, it seems like we should be able to just get rid of this. And it's used, like, out here in this thing, but I don't think we care about that at all. I mean, we can still use that as the way we do the alignment at the immediate moment, but we don't need to store it, certainly. So we'll just leave that because it needs to compute how it's aligned, and how it's aligned at the moment is probably fine. But, you know, we don't really care. Okay. So we still have really weird casting bugs. So, like, we're not casting from the correct locations still. You can tell pretty easily, right? So what's the deal with what's the deal with grape nuts? You know what I'm saying? Why is there no timer? I don't know. You know why there's no timer? We never started it. We never started it. Sorry about that. 3:45. Sorry we never started it. We've only been programming for 1 minute and 30 seconds. All right. Anyway, so yeah, we are still messing this up. So let's continue down this situation and see if we can't find some more bugs before we start stepping through it more. Because, like, we made some pretty big changes, so let's just see if we can make this a little more sane. There's really not a lot to talk about here. I mean, we kind of know this is working properly because we can look at the bounds. So the placement of the bounds seems still roughly correct. I mean, it seems skewed very heavily forward for some reason that I don't totally understand. So, like, maybe that's a little broken, but that's really, we don't care too much about at the moment, right? So we'll deal with that a little bit later when we actually align these. Right now, that shouldn't matter at all. Like, it shouldn't matter how they're aligned. We should be able to fix this. No matter how they're aligned, it should work. Okay. So when we have it all, when we create these voxels, we create the atlas, the spatial one, that all looks fine. The offset is just there for the count. Which, again, I really don't think we care about now. All that stuff had to be very careful before because we needed the walk tables lineup. We don't care about that at all anymore. So it should just be fine now. Yeah. So I mean that all seems reasonable to me. I don't know. I don't think we need to belabor that code very much. But let's go into full cast and take a look at what's going on in there. I also don't know, like, full cast, like, I have no idea what the point of full cast is anymore. It seems like you would just probably weld that into here because there's no point to it. It's not really a thing anymore. Like, it's kind of dumb that these are separated, but, you know. Anyway. So the grid raycast path, which is usually what we call, we're just passing down that initial grid index, which is just coming from whatever the position is in the spatial grid that we get from the light probe P, which is, you know, what we are working with. So hopefully that's all fine. Ray origin is just the 4-wide version of that. We should probably unify these names a little bit. You know, maybe we call this light probe P so that at least we don't have yet another variable in there for no apparent reason. And yeah, I mean, that just seems pretty straightforward. So I'm not sure why we've got such a messed up solution happening based on what I see, but who knows? Let's keep going. So in here we then say, okay, we're going to take the spatial dimensions of the spatial grid. That all seems fine. We're going to get the center point and get the difference from that. That all seems fine. I don't actually know what cell dim is used for. In the 4-wide case. It's only used in a bunch of code that got if zeroed out, it looks like. So I might say, like, let's just lose this. This was like the old stepping code that was non-Bresenham that was crappy. Why I didn't use a Bresenham in the first place, I don't know. It might have saved us that nonsense of going down the walk table route because it probably would have been a lot faster. So that was kind of a mistake. But yeah, you can see I'm just going to remove this. Why does it jump? What is happening there? There's some weird thing happening with undo where it goes to some place that had nothing to do with an undo. Like, we didn't undo anything there, did we? I don't know. Very strange. Anyway, so if I delete this code, then we don't need the cell dim 4, which, you know, just trying to remove stuff here because this is getting kind of like very... there's a lot of dead code in here, so I just want to kind of start cleaning it down to what we actually now still use. So looking at this code, we do need the cell dimension because we're using that for stepping for the Bresenham part of the code, right? We do need the ray weight. That's fine. We don't really care about total cast initiated much anymore. We could probably clean up some of these statistics in the future, but that's not harming anyone, so it could stay. At the moment, we are getting the cell center. That's of the spatial grid. We, again, don't really care. The fact that we have to get this at all is dumb. Like, so that's why there's due there, because we could have we already knew what it was before, so that's kind of dumb. But anyway, this gives us the difference between where we are actually casting from and the center of the spatial cell. That's all fine. At least I can't think of any reason why it wouldn't be fine. And then all the stepping code, again, we didn't change the spatial index rules or any of that stuff, so all that should just be fine. When we go to sample from the atlas, this again should also, I think, be okay. But it doesn't, again, we're having some kind of a weird issue here where for some reason our actual, like, our actual spatial grid stepping seems somewhat off or something. I'm going to turn off debug drawing in its entirety here. So that all I see is just the cast. And it looks like we also have lights being drawn, but I guess that's not really a problem. I'm okay with that. All right. So I guess one pretty odd thing is that what I'm looking at now suggests that the spatial partition is sort of oddly aligned to the grid. But, you know, that really shouldn't matter. But it's a bit odd, right? Like, the spatial partition is now, like, I don't really want the spatial partition to be aligned in that way against the casting. I want you to be, like, in one cell or not, because otherwise we're going to have a lot of numerical precision fiddliness, I think. So I would like to do a slight change there. So when we're actually talking about the casting, and we look at like the alignment when we do these, I would want this to be like a half off. So we took that out before for the spatial grid. I think I still want that in there. So maybe like the voxel dim XY, I'm just going to offset it by half a cell so that it lines up with the corners. I don't know. That's my story and I'm sticking to it. It's not a very good story, I admit that. Okay, so here's us casting from this location, and I just am gonna look to see if these are sane at all. I don't know if they are. They seem pretty good. They seem pretty good. Oh man, check out how long that cast. Hey man, that's light for you. Those photons. Okay, so literally just the fact that we were on the numerical edge was enough to cause that much of a problem, apparently. Also, our alignment is shifty, which is very weird. So we got another problem in here. Like, you see how that's shifting? So our alignment is inconsistent as we move through space, which is not good. So we'll have to fix that. But otherwise, much more stable now, aren't we just? I kind of like that shifting effect. I don't want it in there because it's wrong, but I kind of like it. It's kind of cool looking. So for some reason, our atlas slides, our sampling slides relative to the grid. Why would that be? Because again, the spatial grid should not matter because the atlas grid is actually the only thing that matters there. So I don't really understand how we're getting a shift on the atlas grid. How could that be happening, ladies and gentlemen? Boys and girls. Actually, probably everyone who watches this show is probably not a boy or a girl anymore. They're probably a man or a woman. But men and women, ladies and gentlemen, there you go. So, what would it be? What would it be that would cause the voxel to shift? And it's actually in like the voxel rect that gets sent down. So it's like the atlas grid's min corner got set to something else, like here. But how is that possible? Because it's always locked. I guess, is it because of the camera offset part? That does seem wrong. So the camera offset is a rolling value, so how the heck... How the heck was this working? Am I missing something? So this is the original origin offset here, which includes the actual value that we strip away, right? How the heck was this not causing visible roll as we shifted? What the heck? I don't understand. Does someone else understand? That is totally confusing. Because, right, like when this comes in and you send down here the P values, right? So you've got sim origin P and origin P. So the sim origin is going to be locked. It doesn't roll. It just jumps. But the origin P would roll. And... oh, I see. Because we set it to a round value. We actually round it ahead of time. Okay. Okay. I see what you did there. So that offset is always going to be like a fixed amount that we've squared. And I suppose that's fine. So really, this part here, we could have probably avoided... this is just adding back in this, in a sense. So we probably could have just gotten rid of that. We could have just zeroed the dim here out, and then that wouldn't happen. That probably is how we should have done that. But whatever. So this is now wrong because the number of cells is not the voxel dimension on the diffuse atlas, right? It's actually going to be this cell count. So I'm not sure that actually is the right number to use either. But let me think about what that is actually doing, because I don't actually know. So what that's actually doing is it's trying to produce how large this particular thing should be. But isn't that just... I mean, we already have a voxel for it, so wouldn't you be able to just get the dimensions directly? That seems kind of busted. So I think this is just wrong. And I think what you actually want here is the actual atlas grid's dimension, right? I mean, I don't even know why this isn't asked for here. Maybe we don't have that concept, but we should. Like, there should be a way to ask how big this thing is, which is just the cell dim times the cell count. And there's a total bounds, so that should be pretty trivial too, right? I mean, that's actually the whole thing. So, yeah. So let's just say, what if we said that this was actually the total bounds of the voxel? So that solution atlas grid total bounds. Let's start there, and then let's try to figure out, because I still don't see, though, that's just cleaning up something that shouldn't probably have been happening the way it was happening. But what is going on with the what the heck? We're just seeing so much weird stuff happening that I don't understand. Like, how are we getting that flicker? Nobody knows. And that is just from this. That's just from setting the minimum corner. Can that really be true? Let's find out. Yeah, that's really weird. So the alignment here is really strange, and probably there's a little bit of a deeper bug happening then as well. Because like just by changing the alignment, you can get very strange things to happen, which don't make a whole lot of sense, right? I mean, it just slowly creep along. I would like to draw some more stuff here. So let me draw the actual octahedral values again so I can see, are they sliding their sampling location, or are we somehow sliding the shader's sampling location? Because either one could happen, right? So it almost looks like it's just the shading that's sliding, right? Because like the octahedral values are locked in place. They don't look like they're sliding, and they don't look like they're changing either. They just look like they are what they are. If we zoom in on like that value, you can see it moving, right? But the actual values, clearly do something different depending on where you are. I say. We're getting close. But we're not getting quite. So where's the spatial grid at? Like, what's going on there? Looks pretty solid. Not exactly. So even as the grid slides, as is represented by the cyan and magenta coloring, I don't really see any evidence that like the actual things are sliding. So I'm really weirded out by the octahedral lighting values, because if they're not changing, how the heck is the shader that far off? We must be setting the value, the alignment in the shader must be totally busted. Like when we set that value, it's setting it wrong or something, so that as we slide, we are offset, like, right? Oh, the scale is wrong. The scale is wrong. The scale is wrong. It's wrong. That's what our problem is. The scale is wrong, isn't it? Okay, so why is the scale wrong? Why is it wrong? Somebody tell me why the scale is wrong. If someone else can tell me why the scale is wrong, then I don't have to figure it out. So that would be nice. But unfortunately, you probably don't know. And that's fine. I mean, I'm the one doing the stream. It's my responsibility at the end of the day. I'm not going to blame you. But, okay, so you can see the hot voxel rect here is getting pulled out of the Atlas grid's total bounce, which is what we want. No, it's not. So because we clamp in the shader to the actual maximum value, that probably means that this needs to be divided by actually the smaller value. I am going to argue. Here is my argument. You feel free to disagree with it. It's not going to be very eloquent. I'm going to argue the following thing. When we do when we do our sampling, we do the voxi plus devoxi, right, in here. So the way this works is we're first subtracting to get the vox I value in the first place, right? We are first subtracting the minimum corner, which is set here, which we assume has to be correct because it's just 1 point in space. So unless we were pulling that somehow from, I don't know how that could be wrong. I mean, maybe it is, but I can't think of how that could be wrong exactly. But what we then do is we multiply by the inverse total dimension, right? Now, why we do that in 2 steps, I have no frickin' idea. Like, that should just be one value, right? But because we're using light lookup voxel dim, which doesn't have the -1 baked into it, we're actually off by 1 in this mapping. That's my story. And again, I don't know why we set it up exactly this way. That seems stupid. But that's just kind of where we're at right now, so I guess I won't change it. I don't know. The light lookup voxel dim value, which is for you. This. I think in order to now line up, has to just be, you have to subtract 1 from it, because otherwise you're going to go 1 further than you should when you're talking about which cell you're in. I will say that that's a little ad hoc. I should really work that out directly, but yeah. I mean, it seems like I was right, but I was like a little bit hazy in my thinking, so I probably should have been a little bit more careful, but okay, so let's turn off all of our debug stuff now and see what the lighting actually looks like, so we can figure out how far away we are from this being actually working properly. Well, something like that, if you will, or if you won't. So here's the lighting. Does it look stable? Maybe I should turn off those bounds as well so they're not shifting around. You can see like it's not big enough. We should probably make it, you can see the edge of the apron there, which we want to fix. So we maybe should do that as well, but let's see how we're doing here. Do I see any flickeriness? Everything seems pretty stable except for where we're clipping off the apron. I mean, that looks pretty good. Getting some Z fighting on that ground patch there, but that's probably just somewhat inevitable. We should pick those. We need to pick those values with blue noise. So, looking backwards a little bit, so you can see the alignment here is not fabulous. So maybe we should try to skew that a little bit more. I don't really remember how that code was working. Let's take a look in here, says Casey. To be completely honest, I'm not sure why the atlas is shifted like that. So I would not be able to tell you why the atlas appears to be biased in that direction. Like, do not know. So that seems bad. I should have an argument for why that is the case, and the fact that I don't is not good. What I would ask is, if we enlarge it, does it continue to be biased in that direction, or is it like only one or two off? Like how bad is that actual difference? So like in here we've got these like voxel settings. If we were to enlarge this voxel somewhat, so suppose that this was going to be, I don't know, 20 and 28 or something like that. Which maybe is a little bit too much of an ask for the lighting system, but I don't know. I just want to see what does it look like, right? I just want to see how it's aligned. So it's still like sort of a little off, but not that bad. So I don't know if that is something I should expect or not. I feel like that's a bit confusing. I do feel like that's a little bit confusing, but, you know, all right. So if I go into world mode and I remove the camera rect there, it's weird that these are all drawn in like different places. Should probably have like one centralized place where we can turn these things on and off. You know, maybe that's another cleanup thing we do at some point, is just try to like gather up the debug code into something that makes more sense. You know, and all that. But if we go down to push lighting values, so here's the two, the hot voxel rect. Although, can you even see those anymore? It's really just the camera rect that you see, right? So if we just turn off the camera rect, that should be it, which is this right here. All right, so like if one were playing the game, it would roughly be this. Of course, we do have that debug cast still running. I could probably get rid of that as well by just doing like... Okay, so if we were actually playing the game, it seems pretty reasonable. Like, this would be fine. We do want to make this lighting not look so squarey and weird, which is pretty easy to do now, actually. So we should probably do that. But very stable, I would say. There's a little bit of lag up at the front end because not lag, but hiccups when things get paged in and out. But I think if we added a slight, like, I'm not averse to having a frame or two of lag in the lighting if it means smoothing it out slightly. So we might not have to do wider regions. We maybe could get away with that by just having the T update value be something else. Like, you know, it could be something more like every, you know, quarter. So like 4 frames. Every 4 frames, it's, you know, more or less completely blended. Let me turn off that debug cast as well. Debug pick. So 0, 0. Yeah. Meow. So if we meow along here and we pretend we were playing the game, you know, how grumpy would we be about this lighting? I mean, I think it looks really good. So I think really most of our problem is that we have our lights placed in some kind of weird ways that probably aren't very good. So maybe we fix that part. But overall, I'd say the lighting solution seems very good now. Right? So we also can make this much faster because we're still like validating the entire atlas every frame. And we have the grid raycast debugging turned on. We could turn that off. Because that's also a huge issue. Okay. So we probably aren't really that far off our frame rate either, which is kind of nuts. I don't know, though. We'll have to look and see how bad we are. So we're a little bit not great because with that larger, you know, making the lighting being slightly larger in the lighting region is an issue, for sure, right? Because there's just more of everything to deal with. So having to go to a larger lighting region is expensive, and I don't know. Like, we'll have to see to what extent we can speed things up more. I'd also be kind of curious now to know what would happen if we just cast white noise instead of pre-computed light directions on the sphere, because I don't know, like, it would add some noise back in, but it might be nice. I don't know. So we should try that as well, but I would say we're pretty good to go. This still has asserts baked in, so like it also, like, we got a lot of we have to go through and like now pull out any code that's like old code and stuff like that. And also, like, we do have Handmade internal and slow on, so I assume if we turned those off, we'd actually get more speed as well. I don't really know. Looks like we have some things in our diagram code that didn't get their own, what is that, set origin? The heck is set origin? It's this. It's next to overlay. So it's this, apparently. Let's get rid of that. Render diagrams not found. That's true. Because that's probably inside here, yeah. So we would need something that just stubs that out, right? So like this sort of thing. So this accesses global diagrams group. So the collision recorder, why is any of this stuff on at all? This should not be on in the non-internal build, right? That seems kind of busted. So that seems like something we probably have to fix. Because we don't actually have a way to turn off the editor, I guess, which is pretty broken. That should be on internal, right? Like, that's not supposed to be a thing. So, you know, I don't know. Like, it's probably not, it's not 60 frames a second for sure. But it might be around 30, and this is a pretty old machine. So we might have to do a little more work to make sure that we can actually hit 60 with the lighting on. And dropping the ray count down would probably do it. Like, in other words, if we wanted to, we could do only 8 rays instead. So, you know, right now we're casting 16 per texel, right? We could drop that down to 8, see how bad that is. It might be pretty bad. But again, if we switch to white noise, then we could also be dynamic with how many of those there were, which might be nice as a separate issue. We could try it just to see. If we go to HH sphere, if I remember correctly, we could now delete some of this stuff, like the walk table offset and that sort of stuff, right? So if we were to rebuild the light table and have it cast fewer things, we could see if that would give us the speed back that we need as well. So if we do an HH sphere, W build HH sphere, if we said like 8, 8, and then I don't remember what this is called, like handmade sampling spheres, yeah. So if we did 8 and 8 instead of 8, 16, which I think is what we were doing before, why is that still generating directions? Oh, I guess we still do that stepping. All right, well, whatever. If we rebuild now, what happens? So that's with only 8 rays per pixel. And again, I don't actually know. We should probably have a way to do frame rate counting outside of an internal build. But it could be that actually now it's just the diffuse build is what is too expensive for us. So like just processing more of the texture map, right? If that makes sense. So, you know, we'll see. Can I revert this buffer? Kill buffer. Sampling spheres. So yeah, you can see it's 8 now, right? So if I go to Handmade internal, what is that complaining about? World is an undeclared identifier? Somehow I find that very hard to believe. But okay. So, I mean, now we're easily hitting 30 there, right? So that's good. But it still might be the case that it still might be the case that, you know, I don't know how expensive that sort of blend is, but I would imagine it's pretty expensive. So like if, for example, I took that blend out, you know, like this. If this blend went away, what would happen? Besides the fact that we don't get any lighting, but you know what I mean. So, you know, we're in here, we're running it around 30. We drop that out of there. No change? Come on. That can't be possible, can it? I thought this thing was super slow. Did we really speed it up that much? Why are we so awesome? I guess would be the real question. All right. So then you're telling me that the cast is all the time? Apparently the cast is all the time. Good to know. Well, we've got issues. We still have issues to address. But, you know, having issues to address is not as bad as where we started, which is with buggy lighting. The lighting now looks, I would say, excellent. I do think that we have some issues with like we don't want these like weird pools of light, and we may want the shader to interpolate a little differently, because there is a little bit of squariness there that you get. So there's a couple of things I think that could look better, right? Inside looks quite good, but outside not so much. So I do think like taking a look at that would be good. Separately, also, what the heck is happening there? Can we talk about that? What is that? Why is that cube like sized differently than everybody else? Or is that just because like there's some randomness in this? Maybe it's just because they're randomly picked and one's kind of off to the side. I don't know. I'm just gonna call that a source art bug for now. Anyway, looks really good. Couple things I don't love. So this looks not good. Like, I don't know exactly why we get such a weird... I mean, I know partially that the reason for this is because the interior node here is, like, can't cast because it's in the middle of geometry, so it's going to be blacked out, right? So I do wonder if we might want to do something else there, like set this equal to halfway in between these two or something. Like smooth any atlas, any things that can't cast, they just get set to like the average of their surroundings or something. Which will be less accurate, but perhaps more visually pleasing. You know what I mean? So I don't know. Why is the lighting down here is just casting from up above, right? Because we turned off Z. So it's actually pulling the light from the surface to light down below. So we're about to pull out these lower areas, right? That's going to happen. But yeah. I do wonder now what happens if we add back in a moving light source so we can kind of take a look at how messed up that is. We do have one bug like that we'd have to sort of fix that's going to cause a huge problem with that. So yeah, there's an issue there. But let's suppose we go back to the add player thing, and there used to be like a light happening in here or something. Or maybe, I guess that's not true. It was actually in world mode. It's this. I should look for those temporaries. That can stay. That can stay. That can stay. Lovely. All right, so if we put this debug light back in, we're going to hit a nasty bug that we have to figure out how to solve, which is what happens when a light is basically entirely eclipsing one of the nodes, right? And I think you can kind of see what's happening there with that sort of glow in and out. What's happening is that well, instead of telling you, why don't I just show you? So do you see how the light itself occludes one of the main probes that would be hitting it? So you get a brief moment in between when the super bright light fills everything, and then it immediately gets pulled out of the solution, right? Yeah, in order to fix that, we could make the light be up higher, but what we probably want to do is figure out some way to accurately deal with that fact, like that when something has that behavior of going in there. It's also too freaking bright, so we probably want to reduce the brightness of it considerably, but you know. So if we put the light up a little higher so that it's outside of the that it's higher than the thing, I'm not sure what I'm trying to say. If we that's the size of it. That's not going to help. So the debug light P, if we just make it be up a little more so that it clears, hopefully, the light probes where they are. And I don't know how high we'll have to put it up for that to be true. There we go. So now with us moving a light around the environment, I'm going to turn off the debug drawing there. And oops. Maybe I'll make that a little brighter. And I think, you know, when you see what's happening here, I think you can maybe appreciate as well why the white noise might be good. Because you can sort of see how you see the sampling boundaries when you have a bright light, because of the fact that we're only casting out through certain directions. You'll see that, right? And I can make it a lot more pronounced by turning off the the standard lighting. So if we just get lighting out of the world and we're the only light moving through, then you can really see where it falls down, which is why I wonder if white noise might be now, because we can do it, if we should maybe try it, just see, you know. But so do you see those kind of square patterns? That's just the sampling sphere, right? And if we were casting at noise, if we used sampling that varied over, boy, this looks so cool though. Holy cow, this lighting is awesome. That's so damn cool. We wouldn't have those weird checker patterns. We would have some noise that varies over time, but given how this is working now, that might be okay. I don't know, right? This looks so damn cool, though. Right, but you would even out some of that checker pattern in exchange for some noise. So there's a couple other things we can do too now. Let's also look at some other debug stuff. We should probably make a list of what we want to go through. There's so much stuff now that we've kind of zeroed in on this and we've got it mostly working. There's so much stuff we want to go iron out. We also turned off like our convection sampling, so like that's actually turned off right now, which I don't know what we want to do about that. Like, do we want to leave it off? I don't know. Is it buggy? It might be, right? So that's kind of a separate thing that I'm not sure what to make about it. Okay, so in here you can see the code right here. This code. So if we were to nerf this, right? Now we would have it so that it's actually sampling when it runs out of time, right? So when the light would potentially propagate further. You know what I'm saying? I don't really see any difference though. I'm tempted to just add in some white noise here. I kind of just want to know what it's going to look like. You know what I mean? I'm really psyched about how well this came out. For fully dynamic lighting, literally completely dynamic with no pre-computation, no light maps, and no GPU support. This is 100% on the CPU side. This is pretty darn good, I think. So I'm interested in maybe adding some noise there. I don't know. So, I mean, this is the code to generate the ray direction. I don't know how much, like, that will actually cost us. It might cost us a bit because that's not particularly well optimized. So this may slow things down too much. I'm not actually sure. So I don't know. But if we imagined not looking up into the sample table anymore, so instead of this, right, we just don't do that. And we say ray d single equals this nonsense, right? I think that's all we would need. I think that's all we would need. And the inv octdim, I assume is just over 8 there. So the octdim x. Yeah, so it's just over 8 there. So basically, like, this code is the same code. Let's just take a look. I don't know. This may be a very bad idea. Yeah, I don't know where the heck this is going to get entropy from. I shouldn't have removed it. I removed it. Remember, I was like, we don't need that anymore. We're just using a table. Forget about it. We'll deal with it later. That's dumb. But, yeah, what are you going to do? So we'll have to add a more optimized version of this in here anyway. But if we go to the lighting work and we look and see how we would put entropy in here, we have the sample point entropy. I don't actually know if that is valid. Like, I don't know if anyone's setting that. Sample point entropy. So they sort of are. And so, you know, there's the thing happening with the thing. So maybe that's fine. Who knows? But all right, so the poor solution to this problem. I guess it's just random seed offset. This is not going to be good, to say the least. All right, so maybe or maybe not that's white noise injected in here. This could just be a complete disaster. I don't know if it'll actually work. But so, you know, that's the white noise version. And you can see, like, you do get the flickeriness as you go kind of further out, right? Which, you know, I don't know how likely we are to fix that. What I will say is we now have the nice thing of, like, you can just set lighting octahedral rays per pixel to whatever the heck you want because it's not reading out of a table anymore. So you just be like, oh, yeah, we're doing 32 samples now, right? Or whatever. It's going to be too slow to use, but, you know, you can set it to whatever you want, if that makes sense. Oh, but not like that. You have to set it the same as your sampling, inverse sampling, because otherwise you will just explode with light. Like, you have to have that value match the value that you're using for, yeah, I mean, you get the idea. So if we want to do a ray count here, that is in the ray weight. And like I said, I don't know. This might not be a good idea. It might be that we have to use predefined directions or something. But we'll see. So there's like a slow version, and there's not very much flicker. It's pretty imperceptible. You get some noise in the far out places, but man, like, that's pretty low. I'd probably be okay with that. And maybe you can do some denoising on that, right? Like, over time. So it's pretty good. At 16, it's, probably significantly worse. Like, you can see the noise pretty bad at 16, right? So I'm guessing somewhere around 64, it becomes pretty good in terms of noise level. Yeah, I mean, at 64, you basically, like, wouldn't really know. It's just we can't afford that many samples, right? You can see how slow it is. We can also add some lag. So, if we're only going at 8, or something like that, where you would see it, I wonder if where that sweet spot would be for the lag, right? So, we could make it more laggy, like 10 frames. And that's pretty good. I wish I knew more about sampling and denoising. I like nothing, right? Because I bet we could put some kind of filtering in on this as well that would make it so that you got more use out of the samples we're taking. Like right now, we're probably not doing a very good job, like figuring out how to weight those samples or whatever. But this looks pretty freaking cool. So yeah, I think we could probably call that done for a while. Like, I don't know that we really need to worry too much about this. I mean, that just looks so cool. Like, you'd play a game that looked like this. I don't even think you would mind. But I do think we can do better. I just don't know that we care at the immediate moment, right? So that seems fine. I would say that the entity gen code that's putting in all these lights, I mean, when you have more lights, you don't even notice. It's only when you're in a really dark area you can't even see the flickering at this point. Right? So there's too much light, it looks like, sometimes in these areas. Like, just too much. Because the convection now happens, so we do, like, move light around a lot. So, like, I'm still just enough light to push this, I think, to push that region over the edge. But yeah. We probably want an exposure curve. We don't have an exposure curve right now. We probably want that. So I think that's pretty good. I mean, nice work, everyone. I think we did a really nice job on this lighting. Still has some rough edges, but it's pretty darn good. And yeah. I'm not sure what we would want to do exposure curve wise. And you can kind of see we can still end up in these like overbrighting cirrus like that, where the light kind of propagates out and is very bright, right? And I'm not sure that might still be a bug. I assume that's from the fact that we are carrying a very bright light right now, but it still could be a bug that it's like adding too much light. The sampling that does, yeah, I don't know exactly, but there still could be a bug in the sampling that allows you to end up with more light than you should. So I think that is probably also something we want to look at. So I don't really know. Yeah, the darker one will be what it looks like whenever you're in a region that has no lights, assuming that you're carrying like a light around, right? So, you know, like, well, let me finish what I was doing here first, but we can do an example of what that would be like. So, you know, like, I don't know, this world generation code is such complete garbage that, you know, but if we turned off lighting in like the main room or something like that, um, I, you know, I mean, I don't exactly know if this will do what we want, but I think it will. So, like, if you imagined, right, you're in an area where you have like no light, then in that part of the game, that's exactly what it would look like. And if we pretended temporarily, so move entity is nerfed because we have to remove Z from that. I like that. Don't care about that. You gotta love that. How do you not love that? I don't know. Um, I I just don't know. So where is new P is refined voxel placement? So yeah, if we did like, don't care about that. What I actually want to do here is change this to just auto move the thing. So so it's more like if we say that we don't care about that, then what we do is we say we move it to where it's going and we leave the function. So what I was going to say is if you imagine this was actually, oh God, what have I done? Okay. The diagram end has to be in there, doesn't it? So, you know, totally fair. Although I guess I could have just put the diagram end in there. I don't know why I didn't do that. That's like a smarter way to do this, right? Like that. Yeah, so that's... What? I put a diagram end in there, didn't I? Oh, I forgot the return. There we go. So assuming that I bring the glove with me, like, right, which is the other code that we have to work on now sometime soon. But if we imagined that the glove was more like what the glove actually is going to be in when the game is actually sort of nominally a game, you know, the glove would have a light on it because it's a glowing magical glove or something. And so the glove itself would presumably have that. So something like this. I don't know. I really just have no idea what I'm typing in here, so you'll have to forgive me, but it's gonna be like, you know. I don't actually know where add piece is defined here, but I assume that, like, it is somewhere predefined. Yeah, like that. Okay, too much light. Obviously. So we probably still have a light bug there, because in theory it shouldn't be able to convect like that. And I do think that that probably has something to do with the, like, transmission rule. Like, I assume, and let's double check this. I assume that once you add the, like, that convection rule, that's where you get that from, although I don't know. So we'll have to take a look. But yeah, if we if we turn this back on, does that still happen? Wow, it does. All right, so I think we still have a bug for how we're doing the sampling, such that the light contaminant thing works, because I don't think that it should. And maybe I'm totally wrong about that, but I just don't think that should be happening. But it's pretty clear that if you get too much light in an area, it's able to sort of, like, propagate somehow, and that doesn't make intuitive sense to me. Not saying it definitely shouldn't happen. I'm just saying I don't understand why it's happening. So something seems up. You know what I mean? Something's up. You can see that, like, the light. You can see we need to fix that problem with the light going over the area. Like how is that happening? All right, someone needs to explain how that's happening. So we still have some kind of bug there, but we have no idea what's causing it. Like, as long as the light is kind of in one particular spot, it's able to do that. How is it possible? Nobody knows. So we still have one more bug to find. I mean, we probably have more than that, but somehow it's able to feedback. And we don't really know how. Like, we don't know what's going on there. We're blind. The blacking out part, we know what that is. It's just it hovers over the light probe, right? So if we imagined, that's so weird. What is happening? We have to figure that out. I'm going to be very satisfied when we finally do. But it's like something about the fact that the light is able to just, even it's anywhere I stand, as long as it's stable, it feeds back. Now, why these other lights aren't feeding back, I don't know. Right? Like, why are the other lights not feeding back? They're all staying in one place, so I don't know why that would be. But something's up, right? Anyway, that in terms of that, like, going across and blacking out things, that we know what that code is. That code, the code that's causing that is just the this bit here. And that's preventing you from raycasting out from inside, from inside things, basically. If we imagined just not doing this, that probably prevents the blacking out, but we need a better idea of what it should be set to. So it's still like kind of an open issue, right? So I don't know. No. So you can see now we don't get the blacking out, right? But you still have the problem of it doesn't pick up the light, so it's still not good, right? Like it won't pick up the light while it's over there, so you get like this progressive like dimming behavior, and that's not good, right? So that's a little bit messed up. And also, you know, like we want to be able to crank this to a higher value and not have that light contamination. So we got to figure that out. What do you suppose it is? I think it must be a bug in how we're sampling. The way that we're producing the light sample value is probably just not correct. Like it's probably that we're missing a term in there that's supposed to dampen the contribution by some kind of thing that's more correct. That looks so cool, by the way. Um, that, you know. So what happens if we let you cast out from inside things? So suppose we just didn't do this. I suppose one problem is now you have light leaking through walls. So that's not good because the walls are allowed to cast. So that's probably bad. Right? You can see, yeah, there's no stopping it. So it does seem like I think that pretty much tells us what we need to know. Like our sampling, this code that samples, that does the blend, produces values that are too high. Somehow. Like it needs to take into account some kind of I mean, I just don't like something's wrong. Like because it shouldn't ever be able to produce a value higher than what the light value is, but I guess it could if the light value is that high, then that is just slowly transmitting the light. So, I guess that's harder to say. Like I suppose what I would say about that is it's possible that's just sort of slowly solving the problem correctly. And because we don't have an exposure curve, eventually you will get up to a higher level of light as the things bounce around. And if you don't have any actual occluders, which is what will happen when I did what I just did there, maybe that's actually correct. It doesn't quite sound right. So I don't know about that. So yeah, I'm not sure. I should probably wind down for today. It's already like 5 o'clock. It's time to make some food. Um. So yeah, I guess we'll pick this up again tomorrow. I think we should add an exposure curve in there, and we should probably set all our lights so that they're just between 0 and 1. So like 1 is the brightest light. Like 24 is the highest number. But I don't know. Sandwich Maker was suggesting a simple exposure curve. Yeah, so kind of like a soft knee compressor, basically, right? Um, Send out code download stuck at 346. That's not possible. Did it break? I know I updated like 640 something just the other day. It can't be 346 unless something very weird is happening. Or Sendal broke. I mean, there's a reason we are going to replace Sendal is because it's so bad. So that's possible. But I don't think it should be that far back unless they broke something. So yeah, I guess I'm going to stop for today because we've done a lot of work today. But we definitely, this is very strange, that light contamination. And we're going to have to figure out what's going on there. I don't understand it at all. Yeah, 646 sounds about right. So Team R&B, like, well, I'm gonna end it here for today. We got a bunch of stuff to look at next time, but it's looking pretty darn good, I would say. Yeah, 646. It's maybe a day or two behind, but it's not like 346 or whatever. But yeah, I try to update it. I might, because we should be day 650 today, I think, I'm going to roll the counter on that one so that it will be easier to upload. It was getting very hard to upload because the package was too large. So hopefully now it's easier. Sendal doesn't make it easy to actually update the stupid thing. But yeah, the GitHub should always be up to date. And the Sendal will be hopefully more up to date now because it'll be easier to upload it than it was. But anyway, so I think that's it. I'm going to call it there. And we will pick it back up next time. So thanks everyone for joining me for another episode of Handmade Hero. I will see you all on the internet. Take it easy, everybody.